Hi, good evening, everyone. So, welcome back to plan 258A, right? Okay, so today you're going to present your project. Okay. Do you want to present it in the beginning or you want to present at the end? Yeah.
Prof, maybe towards the end.
Okay. In that case, let's start with the lecture about queuing theory today. Okay. You can go to Moodle and download Technomo queuing rule of thumbs. Okay. The same material is also in Wikipedia. Anyway. Okay. So let me share with you. The slide. Can you see? Okay, so let's start. About in 2012, I started to think how to simplify the queuing theory. Okay, and this is one of the results. So first, let's discuss what is queuing problem. Okay, and then we can discuss in brief what is the mathematics of queuing, and then we discuss about queuing rule of thumb and reduction of queuing. Okay, so what do you think? What is queuing in your opinion, Angelo?
For me, Prof, uh, it's a process of receiving a service so that you wait in an orderly manner and then wait your turn in a specific service rate.
Okay, so do you agree with that, or you have other opinion, Aaron?
Yes, sir. I think queuing is more of when I think about the word queuing, I think about lining up somewhere in a restaurant or in a grocery. I don't know.
So all of you have been experiencing queuing, right? So in this example, the dog are queuing to pee in the trees. And this is the queue in the supermarket. Okay. And traditionally, the word queue probably means waiting line. Okay. And traffic congestion is actually also queuing, right? So this is an example of police stop in China that queue. And this is also queuing. It's by a lot. Iguana probably want to queue to get food. So there are two types of queue. Okay? So this is a queuing in waiting line. And then there's also queue in, we call this bulk queue. Okay? So bulk queue is not really in order. Okay? And probably what you think as queuing is always in waiting line. So, but let's generalize the meaning of queuing. Okay? It's not just the waiting line. Okay? In fact, the waiting line is just one type of queue. We call it first in, first out. Okay? But when we start to generalize the queue in the body called queuing theory, okay, we can create a different type of queue, and we can analyze different type of queue. Okay? So this is an example of a herd of sheep passing through the gate. So they need to queue. And can you see the so can you see this curve here? Can you see the curve? Okay, so it's kind of semicircular curve, okay, that always happening when you need to go in the crowded situation, not just for the sheep, but also for human. This is bulk queue, definitely, not necessarily first in, first out. Okay. And there are certain patterns that we can observe in the queue, in the crowd. Okay. So when you are stick to first in, first out of FIFO, okay, and then you want to enforce that queue, and this is an example of a policeman use the sticks to hit the people who want to watch a cricket World Cup. So the enforcement of queuing discipline is also some issues, whether we really need this or not. Because if you're studying queuing theory, actually the total time to queue, okay, regardless the order, it will finish the same thing. Whether you are using queuing FIFO or using LIFO or bulk queue. So it's in terms of prioritization and in terms of probably the feeling, FIFO is probably better, okay? But not necessarily in terms of the performance for the whole systems. Okay, so in transportation, you see people queue in going to MRT, also in the intersection. So this is very normal situation that you see daily, right? This is in Singapore. Okay, when iPhone 7 was announced, they only sell in different places in Singapore, but these two people trying to get to buy okay, iPhone only in the airport, so to avoid the queue. No, but they did not go out to fly. So in that case, the law in Singapore do not allow them to buy actually. Okay, so they get go to jail just because they want to avoid the queue. Yeah. And question is whether queuing is actually good or bad, right? So for many establishment, okay, or many business, okay, queuing can be considered as a good things, okay, because the more queue, okay, for that business, for example, restaurant, probably people will think, oh, probably that is a good food there. So you will also join the queue. So this is queuing behavior represent the crowd behavior, but not always like that. So queuing is not necessarily good or bad, depending on the context. So in fact, queuing itself is pervasive. Okay, these are example of places where you will see a certain queue, okay, in the bank, in traffic, hospital, and so on. So can you, each of you, tell me, okay, what kind of queue that you experience in your life uniquely, not copying each other? So, have you experienced any queue? Yes, Junafi.
All of them, sir.
All of them?
Yes, sir. Like for example, in our office documents or queued as to which office, as to which a document comes in first, then it comes out first.
Right. So queuing is not necessarily for human, yeah? Including the document in the office can queue to be served or to be signed. Okay. Similarly, inside the computer, probably certain files want to be printed. Okay. So in the industrial engineering, so certain raw material need to queue for the machine to be processed and so on. Yeah? So not necessarily just human. The same thing, music uh, in the playlist queue to be played. Okay, so queuing itself is very passive, not necessarily just human. So, okay, what's the queuing problem? Okay, two things. One is inefficiency. Okay? If you have making too many server, okay, the good thing is the service become rapid, okay? But there are a lot of idle worker. So in that case, underutilized equipment, so the cost is very high. Okay? But at the same time, if you put too little server, okay, then there is long queue, okay, and people become impatient, uh, and then go to other place. Okay? The impact of congestion is very deep. Okay? So, what do you think the impact of congestion in your life? Anyone want to tell a story about that? What is the impact of congestion, traffic congestion probably in your life? Two? Two are, yeah. Yes, Chopin.
Sir, I'm sometimes I become late in class
Hmm?
because of the congestion.
You become
Late in class, sir.
late in class. Yes, traffic congestion. Only late in class.
Yes, sir. When coming to work, I'm a little bit early, but when going out, it's really, sir, rush hour, congested like
Hmm.
that, sir.
Okay, so, and Abi, you want to say something?
Sir, for the effect of congestion in our daily life, especially personally for me, is the level the productivity
Mm-hmm.
I make during the day. For example, once I go home, I have to do some houseworks, but I won't be able to do it. I won't be able to do it because I've spent a lot of time during rush hour in the traffic.
Okay. So productivity reduced because of the traffic. Okay. What else? Yes, Angelo.
When you're stuck in traffic, sir, you're losing opportunity costs
Mm-hmm.
to maybe do other things or learn other things. And
Mm-hmm.
then the vehicle consumption for gasoline is higher.
That's correct.
Uh, that one, sir.
Hmm. Okay. So from my place to last time I'm working at the new, so it's just probably like 5 kilometers. Okay. So but it takes like 1.5 hours and sometimes 2 hours because of traffic congestion. And what happened in 2008, okay, when my children still small, they need to go to school, right? And that one is very, they need to go very early. For example, they wake up at 4 o'clock and then they go to school 5 o'clock, arrive in the school like 7, okay, and then they go home by 5, arrive in the house like 7 o'clock, and then just eat and having take a bath, and sleep again. So every a few weeks they will get sick. Okay, so it impact to the health, and also they get very low in the grade. Mm. Eventually, we decided to buy, say, a space, a condominium near the school, and when we decided that, okay, the children's life suddenly become happier. Okay, they need to walk only to school by themselves. It's only 5 minutes, and from the last in the class, the last in terms of the ranking in the class, suddenly become the top students. Okay? So the impact of traffic congestion is tremendous, beyond the just the time, and activity is also affecting the health. So,
Sir,
cool. So,
uh, in addition po, I'd just like to add that it's also attributed to road safety, because now that drivers are agitated in traffic congestion, they tend to do unrational things. So it's unsafe for drivers and
yes.
pedestrians.
So, because they become impatient, right? So, right. So the correct way is to balance. Yeah. Okay. In traffic, okay, in road, what is the server? Can you identify the server? If you look at the road, something like this one. Which one is the server? When people queue for MRT like this, which one is the server? Anyone have idea?
Bro, for the trains, is it the train operators?
For the train, when you are queuing to open the door like this, the door width is the server.
Mm.
Okay, so for this kind of if the traffic move, okay, actually the number of lanes is the server. When there is a traffic signal there, actually the traffic signal timing is the server. So I hope you can understand the identifying the server is very important in queuing. Okay. Of course, when people wait until outside, that is the train itself is the number of cars in the train is the server. Right? Good. Okay. Let's go back here. So why queuing is a problem? Okay. So there will be economic loss, yeah, for the business, okay, if the customer is kept waiting. Example, okay, simple example that's clear, okay, is the airplane. Okay, when the number of runway in the airport is too little, okay, then the airplane will wait in the air, okay, to land. Okay. That will consume a lot of fuel while waiting, isn't it? So per seconds, they need to spend a lot of fuel just waiting in the air. So that will become the cost. Okay? So the same thing if you sell food. Okay, so food product may be spoiled if it takes too long to reach the customer. Yeah, and if there are queuing for your business, probably you will also lose customer because the customer will go to the competitor. So this is loss of opportunity. Okay. So when we say queuing management, okay, it's management of queuing system. Usually we want to know three things. No? We want to evaluate what is the system performance, okay, and then we make prediction based on that about the future, and then we compare the two. Okay? So including the traffic and transportation. So you need to compare the current existing condition with your proposed system, right? So now, how to measure the performance? Okay? There are many methods, okay, to measure the performance of queuing system. Okay, one is through direct observation. Okay? Later on, I can show you in the next slide. Yeah, basic queuing theory. Okay, you can observe and then take the survey and then calculate the statistics and check, okay, the queuing performance. Another method is to do queuing theory. Again, I will explain in the next slide. Okay, and we can also do simulation. Okay, and the simplest one is actually to use queuing rule of thumb. Okay? So here is an example of simulation. Let me show you. Can you see my Excel? Okay, so this is the example of queuing simulation. Okay, so I set the arrival time, arrival service rate, and so on. Okay, and then we simulate the time. Okay. Can you see? And then, let me see. It disappeared. Oh, yeah. Okay. So, and then we can simulate it here. Okay. So, if I delete this, can you see? What is this? The red one. The red one is the arrival time. Okay. And the green one is the service time. And the blue one is the end of service. Okay. So the x-axis here, okay, the horizontal axis represent the time, okay, and the vertical axis represent the number of customers. Okay. So in that case, if you take the line, okay, if I put the line here, for example, from here to here, with the horizontal line like this. Okay. So if you took the line like this, what is this the meaning? This is the delay. Okay, horizontal line here represents the delay from the time they arrive, okay, the red part, until they start to be served. Okay, and what is the vertical line here for each customer? This represents the queue length. Okay, so the number of customers in the queue. Is it clear? So we can also simulate different type. Okay, so this is using random. And you can start to see different type of queue. Okay. What happens if all the customer come at once in the beginning? Okay. So if all the customer come at once in the beginning, so this what will happen? In this case, you will see this kind of behavior. You see? Okay, so all customers arrive at the same time. So it's vertical. Okay, and this is simpler. Okay, so you can see the horizontal axis again represent here. I will put a line so that you can see. So if this represents the what is this? The delay, right? So of course the delay is represented by the horizontal line here, and the vertical line represent the queue length. Okay, the same thing. Clear? Okay, so this is an example of simulation that you can make if you want to do more detail. So this is the customer ID, and then what time they arrive, what time they start to be served, and then what time they do certain end of the service. Okay. The technique is to use certain or headway. So we need to have a stochastic simulation, and from there we can start to do all the computation of the performance. Okay. Any question? Okay, thank you. So let's go back to the slide. Okay. Now, if you don't want to do this simulation, it's probably complicated, right? So I'll show you a very simple way, okay, that you can also use. Okay, we call it a queuing rule of thumb. Okay. So in queuing rule of thumb, okay, we divided the input and the output of the system. Okay, so the input could be two parts. Okay? One is the customer, and second is the service facility. Okay? The output represent the queuing performance. Okay, so we call it measurement of effectiveness. Okay. So in the customer, you will have, for example, arrival process. In this case, you have a number called arrival rate. Okay. This represents the flow or certain distribution pattern, and whether the customer population is actually finite or infinite. Okay. And then in the service facility, again, you will have a number called service rate. Again, this represents the flow, and it comes from certain distribution. Okay. And you can also have certain configuration, such as parallel or serial or pole. Okay. And in the service facility, you can have a certain waiting capacity. Okay. And you can have also certain service discipline. Okay. FIFO is just one of them. Okay. First in, first out. Okay. You can also have a different type of queuing discipline. For example, LIFO here represent the last in, first out. Okay. Or you can have also some priority queue. Okay. Now, let's go to the simplified mathematics of the queuing. Okay. So in 1953, three. Yeah? One British named Kendall, okay, suggested certain notation that probably will be helpful to classify a lot of different type of waiting line. Okay? So simple Kendall notation is very simple. You have A and then B and then S. Yeah? So three things. Yeah? A represent the probability distribution of arrival. This represent the customers. And then B represent the probability distribution of the service time, okay? The service facility. And S here represent the number of channel. Okay, so then you replace this A or B with commonly used letter to represent that what kind of probability distribution. Okay, now if your process is actually random, say using Poisson process, okay, so you will put A here become M. M represent Markovian. So that can be Poisson distribution for arrival or exponential distribution for service time. And then you can replace A or B with letter T, yeah, if your arrival or service time is deterministic or constant. Okay? And then you can also replace it with letter G if you don't know the distribution, but you know the mean and variance, that means the global general distribution. Okay, so this is an example. Okay, so if you have a TT1, okay, that means your Q arrive at constant time, okay, and then it will be also served at constant time. Okay, so the first T here, for example, appointment system in the doctor office. Yeah. So if your arrival is deterministic at constant, so the first letter here represent the T. Okay, and the second letter here represent the service. So the second T here represent constant coming out. Okay, so if you have TT1 here, then deterministic, and then you have only one server. Okay. Now, the most common queuing system is called MMS. What is this? M is Markovian, and then another Markovian for the service, and then S is the number of servers. Okay. So this means you have random arrival and then random service time with certain number of server S. S means 1, 2, 3, 4, and so on. Okay. In the traffic signal, the arrival is random, so M. Okay, and then the traffic signal is deterministic because it's constant time. So, and S here represent the number of lanes, okay, in the intersection. So you will have MDS. Okay. In the doctor office, okay, you will have DMS. What is that? You have appointment system. So the arrival of the customer is almost constant. Okay. But the doctor serving the customer is random in terms of the service time. And then probably S here represent the number of doctor in that hospital. Okay. So if you don't know the actual arrival or service time, you can use G. So MG1 here represent random arrival and then general distribution for the service time with mean, certain mean and variance. Now, I give you the clue, okay, how to see whether this is random or deterministic. Okay, so when you calculate the mean, and then you calculate the variance, okay, for arrival and then for the service time. Yeah, when the mean is close to the variance, okay, so in that case, you know, variance divided by mean or standard deviation by mean is actually coefficient variation. And when the coefficient variation is nearly to 1, then you know this is actually a random process. So you can use M. Okay. Now, when your variance is actually very small, near to 0, then you have deterministic system, T. Up to here, is there any question? Is it clear or not? So this is the clue, okay, for you to see whether you want to use deterministic or random process. Yeah. Okay. Next. So in my website, okay, in Revolet2, you can check. Okay, this is the. I also put the link in Moodle, okay, so you can put that exactly. What is queuing? Why study queuing? Okay, what is steady state, and then several queuing disciplines. And there are several calculators that you can also use, yeah, including how to do observation here. Okay. So the text of this lesson is already there, so you can also use GGS. Okay, so this means general distribution of arrival, general distribution of the service time, and then just S represent the number of server. Yeah, and this represent the population. The last number here, the population is infinite. Okay, so please check by yourself. Okay, for this website. Now, because most of the queuing system is actually random, okay, so this is probably the most well-known. So we use this called MMS, okay, Markovian, and the number of server is S, and S is discrete, okay. So the formula is like this, okay. If you want to use the calculator, you go ahead, you use the calculator MMS there, okay. And it seems the computation is rather complex because of this sigma notation here, and there is also factorial and then minus. Okay, so first you want to calculate that, you need to calculate the probability of empty systems, and then from there you can calculate the queue length, okay, the system, and the delay. Okay, now the most important part here is actually the constraint. Okay, utilization factor, okay, is actually 1 over S as the number of server multiplied by the row. Row is actually the number arrival rate divided by service rate. And this is the constraint. 1 over S times row should be less than 1. Okay, and this is the one that I use, okay, to derive queuing rule of thumb. Okay, so based on this constraint, okay, from the queuing theory of Markovian with S number of server, okay, we can actually calculate the optimization. Okay, so that means you can actually calculate the total cost. The total cost computed by certain waiting cost per time, okay, per each unit times with queue length, okay? And then CS here represent the cost per server, and then you multiply by the number of servers. So this is the total cost, and eventually you will get okay, this kind of curve. Okay, so this is the total cost, okay, and this is the waiting cost that go down with the increasing number of server. Yeah. And the service cost will also increase with the number of server. Okay, yeah. So then optimization is basically you want to find the minimum total cost here. Okay. Now I also sell this kind of optimization spreadsheet, okay? But at this point you don't need to buy. You can just calculate on your own. Okay. So the math is already there. Oh, so in 2012, I decided to write this queuing rule of thumb, and now become useful for many people. Okay, and the formula is rather simple. Okay, S is the number of server, okay? N is the number of customers. Okay, and then R here is the service time. In this case, for example, you use seconds per customer per server. And then T is the maximum time to finish the queue. Yeah. Again, if this is in seconds, then this is in seconds. So the units must be correct. Okay? Where this formula come from? Okay? So it comes from actually this kind of curve. Okay? When I start to plot between the Q length and the rho. Rho is the surface arrival time divided by surface time. Okay, you will see the curve is something like this. So this represents the number of surfer. Okay, this is surfer 1, this is surfer 2, this is surfer 3, and so on. Okay, up to number of surfer. So look at this. When the number of surfer is 1, okay, eventually it will go up, okay, up to here, and then it go to infinity. Okay, and then you need to increase the number of server, otherwise it will go to infinity. Then when you increase the number of server, become 2. Now you get the green line here. Okay. Again, when the row is almost 2, it will go to infinity. Okay. Then you need to increase the number of server again. Okay. So based on that, you can see where it come from here. Okay. That curve a while ago is come from this constraint. Okay. So what is rho? Rho is the arrival rate divided by the surface rate. Okay. So I can simplify it. Okay. Lambda here, arrival rate, is actually the number of customer per the unit time. Okay. And the surface rate is actually this is the flow. Okay, is equal to 1 divided by the service time. Okay, so when you put the 3 of them together, so you will see rho is actually lambda per mu. So lambda, I put this n over t, and then mu is 1 over r. So the r can go up, right? So in this case, now the u itself is rho over s. Okay, then I can get this formula, right? In that case, you put s on the right-hand side, so you get exactly this queuing rule of thumb. Simple. Okay. Yes, this is what is this? This is the minimum number of server that you need. Okay. This is not the best. This is not the optimum. Okay. This is the minimum number of server. Don't forget. Okay. If you put it less than that, your performance is so bad. Okay. And that's why the value here is larger. Okay. And this is the example. Okay. After I announced that, okay, so about several months later, okay, in 2012, one lawyer in New York inducted me. How can we use this queuing rule of thumb for deciding the homeless shelter in New York? Yeah. So this is the problem. A homeless shelter have 500 residents, okay, and they have only 10 showers. Okay, in average, the person need about 6 minutes to take the shower, right? And even though they are homeless, they also need to work, you know. So in that case, there is a peak hour in every morning, okay, which about 3 hours. So the question, how many bathroom actually needed, okay, for that homeless shelter? Okay, from here you can see this is the N, okay, the number of customers. Okay, what do we have here? The S, the number of server, and what is this? Okay, this is the service time. Okay, but be careful. This is in minute, and this is the performance, the T. Yeah, this is in 3 hours. So, in order to solve this, what you need to do is to put them together in the same unit. Okay. So the S must be larger than N times R divided by T. So N is 5, R is 6, N is minute. So in this case, I need to put this also in minute. Okay. In real number, you get 16.67, but because this server must be unit, integer, so we take the smallest integer. So minimum is actually 17 bathroom. Yeah, since the shelter the homeless shelter only has 10 shower, so the city government need to build 7 more. Okay, up to here, is it clear or not? Any question? So if you have no question, can any of you do the second example there? Drop off link. So this is real school in Metro Manila. You probably know this is one of the favorite school. Okay. Every morning they have okay. So every morning, okay, from 6 to 7:15, okay, they have like 4,500 at the time. Okay, they want to enter campus. Okay. So it's a great school problem. And now its dropping point require approximately 60 seconds. Okay, because they need to bring a very heavy luggage. Okay. The children need to go down and the driver need to go down. So 60 seconds. Okay. And then I computed so that they have of course the length of the car is like 4 meters, but to make a maneuver, okay, I just make it 10 meters. Okay, so that they can have maneuver to go to the drop off line. Now the question is, how long is actually the dropping line so that the children will not be late for school? Can you calculate?
Prof, we
Mhm.
can. Are you sharing the screen?
Oh, no. You're supposed to share your screen. But okay, I will share the screen if you want. This one. So one thing you need to notice here is the server was identified by the school wrongly. Okay. They thought the number of lanes is the one that create the server. Okay. Actually, the meeting point, the drop-off line is actually the server here. Okay. So by not allowing the children to walk, okay, creating a lazy behavior that they don't want to walk, and then it creates a lot of congestion, unnecessary congestion. Okay. So if they allow the children to walk and then we create a meander, okay, and suddenly no more queue, the problem solved easily. Okay. So until now, you can see the taxi in the airport of Naia is also a problem. Okay, they let the taxi queue, and then they let also the customer queue, and then they have only one meeting point where the customer will enter the taxi. So this is silly. Yeah, this is wrong way of thinking. Okay, because actually what you need is a parallel server. Okay, but they don't understand queuing theory, And then what they do is they create only one server, okay, which is only the meeting point when the taxi meet the customer. So this is practically very stupid system. When you create only one server for the whole entire, so you need to make the queue for the taxi, also you make the queue for the customer. Wrong system. Okay. So I hope you can solve this. By identifying the correct server and creating a parallel server. Okay, that is the way to solve queuing. Okay. Initially, they have very long queue because everyone want to drop nearest to the gate. Can you see the problem? Okay. When you want to, when you don't allow, when you don't make people behave well, okay, then they will go to the nearest gate so that the children will not walk too long. And what happened is everyone suffered, okay, because you have only one drop-off point practically. But by setting something like this, drop-off point, okay, and then you just marking, okay, and then let the children, based on their ID number, okay, then you assign of certain drop points. Okay, uniform distribution. Suddenly, you practically have a very short time to all of this because you're creating a parallel server. Do you understand? Okay. So you put the number here, 4,500 cars, and then it's up to you to put in minutes or in hour or in seconds. So I just make it in the same unit, so 75 minutes. This comes from 6 o'clock to 7:15, and then the serving time is 1 minute. So each server space is 10 meter, right? So use the queuing rule of thumb, so you can get that 60. Okay, 60 times 10 meter, that means only 600 meter. Okay. And if you create a meander of 4, left and right, typically only 100 meters, okay, or 150 meters. That's not so long, okay, for the children to walk. Okay. So with the covered walkway, so they can walk easily. Clear? Okay. Next, this is also happening, okay, during the conference. Okay. Conference, international conference with 1,000 participants, okay, during the lunch, okay, in the 4-star hotel, okay, and the participant queue to get their own food, okay, from the 2 sides of table, okay, and then I just use stopwatch to check. Each person requires like 45 seconds on average to get his or her own food. Okay, now question is, how many tables actually needed? So that, in their lunchtime is 1 hour, but they need to talk, they need to socialize. So is it possible to make it in 30 minutes just to take the food for 1,000 people? Identify which one is the server in this case. What do you think?
Is it the table, Prof?
The table side is the server.
Mhm.
Okay. So the table, when you let the people to get from 2 sides, the table side is the server. Okay, so if you know the server, can you calculate how many tables in that case needed? Okay. Remember the principle. Okay. Number one, you need to identify which one is the server. Okay. Number two, create parallel server. When you have serial server, okay, serial server, whatever number of server you have, they are just one server. Remember this. Okay. If you create a serial server, okay, series, one after the others, regardless how many server you have, they are just one server. Okay. Anyone can give the numbers of this functions table? Yes, Shinafi, I will stop sharing.
Is the answer 25, sir?
Okay. Two sides of the table, so
You have to divide it by 2 then.
correct. So you can divide.
Okay. Thank you, sir.
Right. Okay.
So
you want-
instead of 25, sir, so you have to divide it by two
Right,
sides.
yeah. And then get the larger number, the floor, oh no, the ceiling of that. That means you have
Sir?
13. The ceiling means the smallest integer which is larger than that.
Okay.
Okay, so you get 13. Is that correct?
Yes, sir.
Yeah. Right. So each table have two sides. Okay. So in that case, the S is already 2. Okay. 25 divided by 2, in that case 12.5. So the the smallest integer above 12.5 is 13. So if you serve 13 tables, okay, or they can finish in 30 minutes. Unfortunately, at that time, they serve less than 13, so it takes more than 1 hour just to queue to get the food. Simply because this is a transport conference, but they don't know how to compute the simple queue like this. That's the irony, right? Okay. So, this is also real school in Metro Manila. In this example, I want to show you, okay, what they are doing is actually wrong. Why? Because they thought the number of server matters. Okay? But the arrangement of the server matters, not just the number of server. What they do is they do a serial server. So this is a grade school of 10,000 students. Okay? They want to have registration and enrollment, okay? And then pay the tuition fee. Okay? What they do is they create a serial server. Okay? First, the parent need to queue to get registration form. After that, check all the delay payment. Okay? After that, pay all the cashier, another queue again to get the certificate of payment. Okay? Okay, one working day is usually from 8 to 5. Okay? And then they have 1 hour lunch break. Okay? And look at this. Look at the number. The serving time is very small. It's just 36 seconds actually. Right? look at this, 36 seconds, okay? It seems like very fast, right? Okay, so question, how many days is needed to register all the students? Remember, okay, when you have serial server, regardless how many server you put there, okay, there's just one server. In the queuing theory, serial server, okay, all is just one. So, how many days? These all are real life problems, right? That you can see and face on daily basis. Okay. Anyone want to share your screen? Yes, Jinafi, go ahead.
So the answer is 23 or 22 days.
The answer
If
is
we only. Okay,
how many days?
23, sir.
23. The number server is 1. Okay. And then N is 10,000. T is 36. So now you want to calculate
There, sir.
the
Sorry.
capital T. Now you need to calculate the capital T. It is the number of time to finish. Anyone else? Katrina, yeah, go. You can share your screen.
So Prof, here is the solution. So server 1 and 10,000 time is 36 seconds and per day is 8 hours.
Correct.
Already subtracting the lunch break, which
Yep.
is equivalent to 28,800 seconds.
Correct.
And T is calculated to be 360,000 and then divided by the 28,800 seconds is 12.5.
Yes.
Then rounded up to 13 days.
Surprising, right?
Mm-hmm.
Huh? Because it's only 36 seconds, remember?
Mm-hmm.
Okay, but it needs 13 days to finish the queue. Okay, this is the minimum. So why it happened? Because you use only serial server. Okay, and people will feel bad, very bad because of this, right? So I hope using very simple computation. Of course, this is not uh, the optimum one. If you want to calculate the optimum one, you can go to the website and then input later on. Okay. But this is the minimum, meaning this is the worst case. In economic, we call this PEP, the break-even point. Okay. It's neither profit or loss. Okay, so this is the worst case, actually. So don't undermine the queue. Even though it's only 36 seconds, it will create a queue up to 13 days. I hope you understand this, the implication. Okay, yeah, thank you, Adriana. This is correct. Okay, let me share screen. Okay. Now, yeah, how about in the church? Okay, so look at this. Now, the church has 500 members in each service, okay, approximately. So after the worship service, there is a clearance of 30 minutes. Okay, before the next service. The members of the next service can enter. So, and the worship room have two doors. Okay? Each door have 2 meter width. Okay? Now, if you study pedestrian, okay, each pedestrian can pass the door with 0.5 meter width, and the speed is about 0.1 meter per second. Something like that. Now, the question is this 30 minutes clearance enough to let the 500 members out? So question number one is actually, which one is the server in this case? So clearly the server is actually the doorway, because each pedestrian can pass this one. The doorway matters, and the number of doors, of course. So the sum, okay, multiplying between the number of doors and the doorway, that is the server. Okay, with that clue, okay, you can calculate whether this is enough or not. Yeah, this is the queue to enter Vatican. Anyone want to share your computation? Yeah, this is a relatively small church, so it's only 500. Yeah. You know, the mega church there in Puerto Manila can be several thousand, isn't it? So with that, you can also reverse. No? So knowing the clearance between the two services, you can also check what is the number of doors. Okay. The same technique you can also use for stadium, right? So that they, for example, for evacuation and so on. Anyone want to share screen? Yes, Joven, go. Okay.
Hello, sir.
Yeah,
Is it viewable already, sir?
yeah, I can see that. Right. So the speed inverse, okay, that represent the
Sir, just get the first the S. It's the two doors times the width divided by the 0.5, which is the, you call this, the meters, um a pedestrian can cross the door with a 5.5 meter width, sir. That's a 0.5 here, sir. So I got
So,
the S of 8.
yeah,
Then
if
for the
possible,
speed,
Joven, can you put the unit so that we can see? So 500 is
okay,
people, right?
people, sir.
And then S8 is what?
Pedestrian, sir.
Or people also, yeah, okay.
Okay, sir.
And then the speed is,
Um, Given, sir, na it's 0.1 meters per,
is it meter per second or
crowd speed, sir, the crowd speed.
okay,
The speed of crowd entering.
meter per second, okay. And then what is 10 there?
Is what, so so I just get the inverser, so of this speed, so it will be the unit will be seconds per
Hmm,
meter of
second.
what do you call this?
So that speed is also meter per second per pedestrian.
Per pedestrian, sir.
So the
So I
speed,
just got the inverse,
the 0.1.
second per meter per pedestrian, the unit of this speed inverse, sir.
Okay,
Then I get the teaser with the formula of N times R,
okay.
or the speed inverse, the
And then
500 times
divided by,
10
okay,
divided by the people or the pedestrian. So
okay.
the unit will just be seconds, sir.
Mm-hmm.
Both meters will in the per people will be cancelled, sir. So converted to minutes,
Yeah,
625 divided by 60, it's
yeah,
10.41, which is much lesser than the 30 minutes, sir. So it can
correct.
accommodate.
So that's more than enough. Okay,
Yes, sir.
good, good. So it's important to represent the unit correctly so that you can check. Okay. correctness. Okay, thank you. Okay. Mm. No, so that's exactly we have here. So this represent the meter pedestrian, so we can calculate it as seconds per pedestrian. So then you can get that values. Okay. Now, using the same queuing rule of thumbs, okay, now you can compare which one is actually better. 6 person doing a specialized task in series, right? Okay. In this case, say the average service time is 30 seconds per customer, or they perform parallel server, okay, with average time, of course, increase to 1.5 minutes per customer because they are not specialized. Okay. So the question is whether they need to be specialized or not. And this is comparison between series and parallel. Okay, look at this. Series is not necessarily worse. Okay, so if you put that into numbers, okay, so you can compare. Okay, T1 is 90 seconds per 6, so that is 15 times 10. T2, okay, with one server is actually 30 times 10. So you can see that specialization is not necessarily good things. Okay. Why? Because you create a serial server, that is the problem. Okay. So specialization is only good if the service time can be decreased so much, okay? As much as the number of serial server. Okay. So remember, yeah, if you want to create solution to the queuing problem, number one, identify which one is the server. Okay. Number two, remove the serial server, change it into parallel. Clear or not? Okay, so look at the summary of what we have discussed so far. Yeah, so we already see that the server is not necessarily the human. Okay? Can be the size of table. Okay? Can be the length of dropping point or the length of meeting points. Okay? Can be the number of vehicles and capacity. If it is an elevator, so of course the number of elevator and the capacity itself. Or maybe the number of doors and the door width. Okay? Or probably the real server is the number of people. So you need to identify which one is the server. That's the first part. Okay? And then you need to make the server parallel rather than series. Okay, so sometimes when they say, "Oh, I'm doing self-service," okay? In that case, very nice, isn't it? The number of servers become infinity. Okay? But in this example, okay, for example, they have self-service gas station. Okay? So the number of gas pump is actually the server. The same thing with ATM. Okay? The number of ATM machines become the same. Okay? Again, in the self-service restaurant, okay, the tables with the food are actually the server. So by wrongly identify the server, they thought this is self-service, but they are actually not. Okay? The real self-service is you can make them into everyone serve themselves via, for example, via internet. Okay. So this is an example. The ideal self-service can be approached through what is called distributed server. Okay, for example, if you let the people to do written part of the driving license test via the internet online, okay, filling the order via the internet, that one is actually a self-service. Long time ago, I do what is called pedestrian experiments in Penang, okay, and then we have only 1 hour to do the experiments, and I created several server to distribute the material, for example, the hat, and they need to fill up the consent form and so on. Okay, and taking so long. Okay, knowing the we need to create a parallel server. So instead of making a boot for each of them, so I asked everybody go to the class, okay, and then distribute immediately. Everyone will distribute the material in the class. Okay, directly they are filling up all the form at the same time. Then we created actually self-servicing. So in parallel rather than a few number of server. Okay. So the question is, can we actually reduce? Can we actually eliminate queuing? Can we actually remove traffic congestion? This is very important question, right? $1 million question. Yeah. Can we actually remove or reduce queue? Okay. The answer is yes. Okay. So to understand this, we need to generalize the definition of queuing. Okay. So in traditional way of thinking, queuing is waiting line. Okay. If you just use this definition, you cannot solve any queuing problems. Okay. You can optimize, okay, you can increase the number of servers, okay, but this will not solve. Now, we generalize, okay, what is queuing? Definition of queuing. Yeah? So generalized queuing definition is it's a process, okay, where the people, material, or information need to wait, okay, at certain time to get the service. Okay. So look at this. Okay, I've generalized definition of queuing system based on the purpose. What is the purpose? The purpose of queuing is to get the service. So you have a transfer of information, transfer of material, or people, or things, what between the customer and the server, isn't it? So in this drawing, traditionally queuing is just waiting line. Okay. Now, in generalized queuing, it's a process where people, material, or information need to wait to get the service. Why this is important? Okay. Because now we can separate material from the information. Okay. Look at this. Now we can separate, okay, the demand from the supply. Okay. So customer represent the demand. Okay. Those identifying customer is easy. Those who seek for service, they are the customer. Okay. And those who provide the service, they are the server. Okay. Not necessarily people, can be anything. Okay. And then the station, okay, or is the location where the single line form in front of one of several servers. Okay. With that, now we can actually generalize the whole economic system, okay, which is based on demand and supply. For example, in logistic distribution, okay, from the raw material go to the factory, from the factory go to the distribution and the center, and then go to the smaller shop, okay, probably, and a bigger shop and then smaller shop, and finally go to the customers. Each of these are representing queuing system. Okay, they can be connected in series or parallel with each other. Okay. Now look at the detail, okay, on traditional queuing. Okay, say imagine you are in the supermarket or in, okay, and you arrive as customer in the queuing system, okay, in the cashier example, okay, and then what you are doing, you are waiting, right? in the waiting line. And then you are being served. Okay, the third step is you are being served. Okay, what happened when you are served? Okay, so you transfer the information to as customer, transfer information to the server. Okay, what is the information that you transfer? Maybe the order, maybe the item that you purchase, probably your ID, okay? Probably your goods that you want to buy. Okay. Second, the step is the server will input the customer data, probably by scanning, probably by typing, and so on. Right? And then, okay, the server will do the order processing, probably preparing the item. The cashier will get the money, okay, or using the credit card and so on, yeah, for the processing. And lastly, we'll transfer the material or information from the server to the customer, yeah, probably the food, the receipt, the change, or document, and so on. And after that, customer will finish being served and exit the system, right? Or go to the next stage of the queuing system. Now, look at this, all of this. Can we separate information from the material? Yeah. If you can separate the information from the material, then the information, okay, can be put via the internet. Yeah. Only the material should be queued. Okay. So the real necessity for queuing is for the material, not for the information, because the information can be passed via the internet. That's the principle to reduce or to eliminate the queue. Okay, so information transfer can be transformed into the internet, while the physical things, the material, the people, cannot be transformed. Okay. Then the question is, does the system really need to transfer the physical things or not? Can you distinguish which one is information and which one is actually the material, the physical things? Okay, so discussion. This is probably one of the most important discussion. Money is material or information? Physical things, money, or actual information? Anyone? Money. Can you answer?
Sir, I'm sorry, I did not hear it properly, sir.
Money. Is it material or information?
Money, sir, is money material or information?
Yep.
I think it can be both.
No.
Well, sometimes money can buy information.
The essence of money is information. That's why you can transfer into the internet, yeah, via the bank transfer, isn't it? The money that you hold, yeah, is actually information represented by that paper money or coins. The essence of money is not the money, the material itself. It's just information inside. How about the key? You have key. Key is information or material? Yes, the key. Okay. Key is information or material? You always hold the key, right?
Material, sir.
Oh. You think key is material? Wrong.
I think it's information because
Okay.
there is a code in the lock.
There is a code in that key. Okay, that represents the length in millimeter. Okay. So the information they coded into material. So the essence of key is not the material itself, it's the number. So that's why now if you know that, say, imagine you have a hotel for reservation. Do you still need to have a front office? You don't need to. Why? Because you can transfer the key number of your hotel room via internet, via email. So you reduce or eliminate the queue. All the government job mostly are information or materials in your office.
Information, sir.
Exactly. So in that case, you don't need to go to office. This is recorded, I'm telling you. Okay? Because it transfer information, so you don't need to go to office. Okay? All the government job that is just require information transfer. You don't need to go to office. I've been talking this a long time ago, before COVID. And everyone, when I give seminar about queuing, everyone will say, impossible. But COVID does that. What they said impossible now become possible. And strangely, after the COVID done, okay, they come back again to the old ways. They did not learn the lessons. Can you see that? They did not learn from queuing theory. Okay, I hope you can keep this kind of understanding. Separate. If you want to solve traffic problem, the Department of Information and Technology should be merged with the Department of Transportation. Because you need to increase the speed of the internet, make it cheaper, so that no more traffic. That's the way to solve the problem of traffic. Not to build more road, to build wider road. That's wrong. Can you see that now? Okay. Make it into information superhighway. That's how to solve the traffic problem. Okay. No more going to school if they are not doing the exchange of materials. You got it. Okay. Separate the material transfer from the information transfer. Then you solve traffic problem. But understanding which one is information and which one is material is the essence. If you still think that key or money is still material, then you are in the wrong side. Okay? They are just information embedded in the materials. Okay? Oh, any comment? Go ahead. Yes, Sinapi.
Sir, this is just like a sharing of what I have experienced since I'm working in the government. Because well, now we promote the work from home setup because of what happened in the COVID-19 pandemic.
Right.
However, for example, however, the department is still pushing that everyone will come to office, report to office every day, and which contradicts your answer, your theory that since information work in the office, like our materials, our documents is information, then
Mhm.
we can just stay at home since you can transfer the information virtually.
Correct.
But then comes the the procurement law of the Philippines, which requires submission of like hard copy documents. So you really have to
You
also
don't need
go
to.
to the office. That's
Hard
the
copy
that's
documents is not materials. Hard copy documents. In fact, if you are go into the environment part, right, you don't need to make
yes.
it hard copy.
But
You should
sir,
remove
yes,
that
sir.
requirement.
Well, that's the idea, sir, because now we have the um modernizing the technology of the government, which is actually using paper in
Paperless
promoting
society.
paperless transactions.
Correct.
But then some government offices still promote the use of paper to submit the documents, which also contradicts the policy of the Philippines in modernizing the and promoting paperless transactions, as well as your theory that the that information is can be transferred virtually. And for us, like government offices, not to really work at the office set.
Correct. So I understand this takes time for the mindset of the people to change. Okay, but I hope through this kind of discussion, okay, you can explain to other people. Okay, I hope this lesson liberate you. Okay, so again, these are the steps, okay, in queuing analysis. Yeah? Number one question is this queue necessary or not? Why do we need to queue? Why do you need to go to office every day facing the traffic? Does that queue necessary? Okay. Again, the answer is this, yeah. Separate the information from the material. If that queue not necessarily, remove that queue. Okay. If that is only transfer of information, that is not necessary to queue. Okay. If that is transfer of materials, yes, that is necessary. Remember, all documents are just information. They are not materials. Just change the mindset only and then solve all the problem. Very simple, isn't it? Okay. Number two, for the material queue, okay, you need to identify the parallel server. Okay, and then look at the formula here of queuing rule of thumb. Then you can start to see, right, easily, isn't it? So if you want to improve the real queue, yeah, so of course you need to increase the number of parallel server. Hey, the number of parallel server, not the number of server. Okay. So then, of course, look at the formula here. You want to reduce the service time, isn't it? Okay, and then you can reduce the number of customers or increase the time period to serve the performance. Okay, when you say mean service time, that is the same as 1/4 service rate. Yeah, like what Joben was computing a while ago. 1/4. Okay, but if you look at the step here, then the most important is probably number one and number two. Okay. Always ask, is this queue is necessary or not? What do you mean by necessary or not? Is this transfer of information or transfer of material? Food delivery is transfer of material. You cannot solve that. Okay. At this point, using our current technology, yes, they are necessary. But transfer of documents, transfer of money, registration, okay, what is that? Police document, whatever document. Okay? They are just information. In that case, that queue is not necessary. Remove that. Okay. I hope this lesson helpful for you. Traffic congestion can be solved. Look at this. Okay. 20 to 40% of the trip purpose is actually compulsory, which is for work or for school, right? Okay. So if you remove just 20 to 40% of this unnecessary, okay, then no more traffic congestion. You don't need to build wider road. You don't need to build more road. What you need is actually to build information highway, increase the number of internet speed and reduce the cost of the internet. Okay. And of course, improve the management. Yeah. So look at this. Why the employer in the business or government probably they don't want people still work from home, okay? Because they cannot control, they cannot monitor well, right? So it's a problem of management rather than the problem of the queuing itself. So it spill up to other case. Correct. Okay, you are laughing. Right. Okay, so improve the management style, so improve the tracking situation. Okay, how to monitor the job, isn't it? Rather than okay, solving the problem. If the problem is in the knee, don't give the medicine to the head. Okay, correct. Okay, so I hope you check. Okay, what's being transferred in all of this? Okay, in the bank, material or information. Mostly information. In the traffic, okay, some are information, some are material, right? Okay. For construction work, of course, they must be there. They are material, isn't it? Okay. So, hospital, you are sick, so it's material. The person, right? So, but most of government offices are actually information. Supermarket, materials. Restaurant, material. Immigration. What is this? Information. So we can remove this one. In fact, Singapore already did that. You see, gasoline station, materials, right? Okay. Why I repeat the same thing? Okay. Airplane wait for the runway. Yes, this is material. Parking lot, the cars. That's the car itself. Yes, it's a material. So music, playlist, and so on. So look at this. Yeah. In the queuing, what is this? This is material or information? If they are material, that queue is necessary. If they are information, okay, transfer that to the internet. Or at least some of the information you transfer to the internet. Then you reduce the queue a lot. And then identify which one is the server and the customer. Yeah. If you look at the new definition of queuing system, then you can start to see the whole economic is actually also queuing system. Okay, from factory to distributor to large retailer, okay, and so on. They are actually a queuing system. Okay, so what happens if you cut short, okay, from factory directly to the customer? Cheaper, right? Question is it actually more efficient or not? Yeah. Any comment, any opinion? Yeah, when you cut short from factory directly to the customer, okay, the system is not necessarily more efficient. Okay, now the factory is doing all the tasks that actually not necessarily that done by the distributor and large retailer and so on. So in fact, the middleman, the trader, okay, make the system more efficient because they distribute more widely at certain cost that must be shouldered by the customers. Okay. So, well, of course, we need to compute the system, yeah, in more detail to decide which one is more efficient or not. So, when we have the current economic is actually based on what is called hierarchical system. So in this case, in hierarchical system, the number of servers is actually less. Okay. In the flat parallel system where the factory directly to the customer, okay, you will have a lot of server. The factory need to set up, okay, a lot of parallel server. Okay. In that case, not necessarily more cost effective for the factory. So, okay. For the sake of discussion, can you state what most people think as material, but actually they are just information? Any idea?
I got a guess, sir. Land. Land.
Land? Oh,
Because it's awarded to you maybe by the previous
government.
owner or the government or the private sector, but it's uh if you
Correct.
won't make physical boundaries around it, but you have a paper saying you own it, then it's information.
Okay. So the land itself is not the land, actually. The right that you have is actually an information. The right is based on agreement or based on the government claim to you, right? Look, you don't really actually own the land. It's just an agreement. Say, for example, if the government collapse, you probably don't own that land anymore.
It's a privilege, sir. That's why
Correct.
we pay taxes.
Correct.
Mm.
Okay. So if the government change, probably that last agreement can be nullified. So it is an information. That's correct. Absolutely. Anyone else have any other opinion? What?
I-
Go.
sir, professional license
Professional license is
is
not the card.
the card. It's actually an information, but
Correct.
most people okay.
Yeah.
Most people take it as only as material
Oh,
material.
yes. So it's not the card that matters. Okay. It's the information inside that card. The same with ID. Yeah. So the ID is not the ID card that matters. It's the information in the ID card. In that case, you can replace with your own face. Correct. Anyone else? Yes, Chopin.
So in relation to what Abby said, I'll just continue with us. There is what we call here in the Philippines the CPD requirements. It's just an information, sir, but if you're continuing practicing your profession, there's no need for that such thing. It's just, sir, additional, what do you call this? Expense. So it's just information from the seminar holder like that, but it's not, it's useless
So
based on
they
my
are just
opinion.
information. Okay,
Yes,
you
sir.
can do it online.
Yes, sir. With no payment, sir, like that. So yes, sir. Can be done online, less resources to be used, sir.
Did you ever queue to get police clearance?
Here in the Philippines, sir, it's not really that important already, sir, because we
Ah,
have
now it's not
the
important anymore. Okay.
it's not really a major requirement, sir. Unlike we have the NBI clearance, sir.
Oh, NBI clearance. Okay, the
Yes,
NBI
National
clearance.
Bureau Investigation.
Okay,
Yes, sir. We
so
are
is that
queuing there, sir.
information or materials?
Formation, sir.
So do you need to queue?
In the Philippines, yes, because money talks.
Oh, you can suggest that actually that can be done by machine. Okay,
Yes, sir.
so that no more money talk.
Good luck, sir.
Good luck. Okay, so these are the examples. Okay. How about your job? How about this class? Education, right? It's transfer of information. That's why we can do it online. You don't need to do face to face. Yeah, including seminar, conference. Okay. Yeah. Oh, your house is material or information? Your house is material, right? So I put here, is a key material or information?
Formation, sir.
Actually information, yeah. Okay, so this is also information. Okay, so there are new technology that can actually transfer that in the future probably. Anyway, so how to eliminate the queue? Okay, by identifying the material from the information, okay, we'll be able to transfer material queue into information queue. Okay, so in that case, work from home, okay, online learning and online meetings will contribute to removal, okay, of traffic congestion. Yeah, the same thing like removal of hotel registration and so on. Okay, we can put directly, if you book the hotel room, okay, then you can directly go to the room rather than need to queue in the registration in the front office, right? So look at this house, okay? I understand house is material, okay? But in the near future, okay, using a 3D print and robot, probably we can start to remove, okay, some of part of the design, okay, some part of these material things into, okay, information as well. Okay. So in that case, you can start to see many things going to separate the material into information, and then the information can be put it into the technology, yeah, solve that. Okay, so then you probably start to think based on the queuing theory alone. Okay, what will be the future technology affect us? Okay. What will be the impact of internet speed that is very high and very almost zero? Okay. Nothing to pay for the internet cost. Okay. What will be the impact for the future of job? What will be the impact of the future of school? Okay. Or the future of congestion, and probably the family relation and so on. So you start to think about that. Okay. So you can use the rule of thumb, okay, for first approximation, and then after that, you can use just generalized queuing definition, yeah, to eliminate the physical queue. So I hope this lesson helpful for you. Okay. So anything to discuss about queuing theory? I hope this is useful. Okay. Yes, Janafi, you want to say something?
Yes, sir. So I just one sir,
Comment.
probably few question.
Mhm.
Since I don't know if it is just a sharing of experience or from my job, since we are actually providing trainings and seminars to local government units in our region. Um, During the pandemic, we did the online since we cannot really just help our activities because of the pandemic. So all the trainings all the seminars are conducted online. And well, it's efficient for us as government employees since we do not have to travel long ways or we don't have to allocate a travel period of a long travel period to provide these trainings. At the same time, it's cost efficient. We don't have to shell out a lot of money for the training. But one effect is that for like our clientels, they are saying or the feedback says that they do not learn anything if we do it online because it's hard for them to focus. And then, of course, if they are saying that it's hard to focus because if they are in a online setup and they are situated in their office, there's like they do multitasking, so they cannot concentrate to the training that they are attending. So I think it probably does defeat the purpose if we do eliminate um there's like you have to compromise with the quality or like there's a effect in the quality of work probably or the training if you're providing a training to your clientels because they are used to do trainings in a face-to-face setup. But now if we promote or like if we promote the online setup and try to eliminate the queuing, the traffic through providing online trainings instead of having them in one venue, like the impact for our jobs, sir,
Okay,
or
so
probably the quality.
several things can be put into consideration. Okay, number one is the management, right? So, how are we going to check if they are actually understand or not? Can they get the actual result or not? That is management part, no? And then monitoring. Okay, do they actually, for example, during online class, I really hope that you open your camera. Okay? It's not for the sake of opening the camera, but actually to see the eye contact. Okay? Based on the eye contact, we can actually the same thing as offline. Okay? So, second is also mindset, no? Because you think that you are far away from the other person, then you start to see, feeling that, okay, I can do any other things rather than concentrate in this training. So it's a mindset problem rather than actual things. Okay? So we are not used to yet with the actual doing online training. Okay? Next, probably also the internet, the cost and the speed. Imagine if the cost is very low and the speed is very high, what will happen? Okay, and the screen is very big. Then you probably will see each other. It's like offline. Imagine that. Okay, because now the wall is actually your screen. Imagine if your wall is actually your screen and you will see each other like, we see it offline, but actually we are far away. Is it possible? Yeah, technology will make it possible. Okay. So at this point, screen is very small. Then you start to see other things, do other things. We cannot see you fully. So yes, so there is some time until the fully online will go there. But look at this. If we don't start from now, okay, it will not go there. So let's build this up so that we will go into that direction. Otherwise, it will be stuck in here like a dinosaurs, isn't it? So let's change. Okay. Start with us rather than change other people. Okay. So with this, I want to thank you for all the lessons that we have this semester. Okay, and now is your time to present your work. Go ahead, who will present first? Everyone is
Prof,
proposed.
uh,
Yes,
our group would like to present first.
okay, Catherine, go.
Hello.
Yeah.
Ay, hello, Prof. and classmates. So our group is composed of Kat, Pao, and myself. Our project is about the traffic management plan for an intersection in Mabalacat City, Pampanga. Next slide. Next. It would be introduced by Pao.
Mhm.
Good evening. Sorry. So this is
Medyo-
the
Okay.
sorry. No, go ahead. Sorry.
Yeah.
Malakas na. Okay.
Okay, thank you. So this is the subject intersection, exactly where Mabalacat, the word Mabalacat is in.
Mhm.
It is a national road intersected with a provincial road,
Mhm.
and this road is generally congested in the morning and in the evening. It has 4 lanes from north to south and only 2 lanes from east to west. And the edge of or the end of this Hidpuyat Avenue or this Hidpuyat Avenue is actually an entrance to a Freeport zone. That's why it's really congested in the area. The objectives of this study is to analyze the current traffic condition on the study area or in the study area, test proposed traffic management strategies to mitigate the current traffic issues, and to evaluate the best suitable mitigating measures using economic analysis.
So our conceptual framework starts from data collection. Next slide.
Mhm.
We have the local public transport route plan of Mabalacat City, and it has the volume counts in 2018 as well as the number of passengers transferred. So we extracted those data from that reference. Next. For the current scenario, we had the peak hour analysis and vehicle composition and the uh, vehicle occupancy ratios. And then next slide, we measured the level of congestion in the road section level and the intersection level. And then next slide, we propose mitigating measures and made scenarios out of them. And then next slide, and then evaluated the cost and benefits using vehicle operating cost and travel time savings.
Mhm.
Next. For the current condition, Pao would present.
Oh, thank you. For the current condition, let me first discuss the land use in the vicinity. Land use refers to the use of the land or what's supposed to be built and done with that certain land. So this area, the gray lines are the roads, while the gray line with the broken outline is is a supermarket, which is a factor in this area. The red the red lines or the red figures are commercial establishments. The yellow are for residential areas. The blue are for institutional areas like school and churches. Next slide. Well, for the road network, the thickest line from north to south is the MacArthur Highway. Uh, the Imelda Marcos and the Hill Puyat extension are newly opened roads. The Velasquez Avenue is one way going to south and east. The Ligtasan Street is a one-way street going to south and east again. While the Star Apple Street, Langka Street, Grape Street is a two-way street bypassing the main intersection. For the growth rate, you can see on the graph that the growth rate for traffic is not steadily increasing, but it's generally in a linear increasing growth rate for 6% per year or 6.11 3% per year, with a growth factor of 1.34. And that's between 2009 and 2024. With a growth factor between 2019 and 2027, we use 1.607. This pie chart shows the or how much certain vehicle type occupies the road or uses the intersection. The biggest would be passenger car. The next would be motorcycles, and then public utility jeeps, and then bicycles, and so on and so forth. And this would be the peak hour. 6 to 7 a.m. is the peak hour, while the off-peak would be 2 p.m. to 3 p.m. And again at 9 p.m. to 10 p.m. Vehicle occupancy factor. Personal cars is considered for 2.4, PUJs or jeepneys for 10.8, buses 29.3, small trucks for 2 passengers, and that is light trucks also. Bicycles is 1.7, motorcycles at least 2, and bikes for 1. So for the traffic control, as you can see, we have traffic lights in the area, but it is not functioning because when it was operated in the early years, it causes a longer queue than the usual. So that's why the local traffic enforcers opt to manually manage the traffic condition. For the issues and concerns, as you can see here, this is the intersection, and this one is going to the Clark Report Zone for the west part. East leg is going to the what do you call this? The expressway, sorry, the North Luzon Expressway, which is a major road for us, for the city, and going north and going south. As you can see here in the satellite image, the distance from the intersection and the pedestrian lanes, that's between 20 meters to 40 meters. As you can see, or as you know, the distance from the intersection and the pedestrian lane should be closer because for the reason that the turning vehicles cannot see early the crossing pedestrians, that way it can cause trouble or it can cause crashes, road crashes. Next, please. This is a screenshot of a video. I can see Prof. Nad. Okay. As you can see in the screenshot, there are wooden poles along the corners of the intersection, which generally should not be there because it affects the safety and the passability of the intersection. And there is also we also installed railings along the corners, so no pedestrian could cross near the intersection.
For the current condition level of congestion, we converted all the vehicle types into one passenger car unit and then got the capacity from the highway planning manual of the Philippines and computed for the ratio of the volume over the capacity. So if the ratio is greater than 1, it means that it already reached its capacity. So as we can see here, the heat map shows that in almost all the time period, the capacity of the road is already reached. So we also got the level of congestion at the intersection level using LOS based on the delay. We used PTV Vistro, software that computes delay with the capacity and then inputted the peak hour volume and the road configuration. So here we can see that there would be 35 minutes delay at this intersection alone per vehicle. Next. For our mitigating measures, next slide. We considered installing traffic signals. So for with and without rerouting. So here is the facing for that. And then we tested if the signal or traffic signalization is warranted. So it passed the warrant 1 criteria. Next. And then we also tried rerouting the vehicles based on the available routes in the parallel roads. So we assumed here that 30% would still be using the intersection and 70% of these routes would be transferred to the alternative routes. So these numbers are representing the number of vehicles that were rerouted. So this is only an assumption for the 30-70 share. So for rerouting, it shall be assumed that yeah, and then the west leg will be converted into one-way road. So 100% of the volume would be rerouted to Velasquez Street, the one in the southeast direction. And as a result, 30% of the demand in the intersection was cut off. Yes. Next. So we also devised scenarios to be tested in the software. So scenario 1 is the traffic signalization and moving the pedestrian crossing near the intersection. Number 2 is the rerouting scheme. Number 3 is the combination of the two. Next. So for scenario 1 and base scenario, since we did not reroute the volume, the demand remained or was still the same. But in scenario 2 and 3, where we rerouted the vehicles, we can see here that at the intersection road sections per approach or per leg, it was it the volume over capacity ratio decreased. Next. For the intersection level where we measure the delays, it can be seen here that there is an increase in delay when we got the scenario 1 for traffic signal alone. And then for rerouting, it was decreased. And then for traffic signal and rerouting, it was further decreased. Next. So scenario 3 has lower delay than scenario 1 because the total green time per hour is higher in scenario 3. So since scenario 1, traffic signal, both of them are traffic signalized. Scenario 1 has more facing than scenario 3, then the intergreen is minimized in scenario 3. Next. For economic evaluation, here's Kat.
So, good evening, everyone. So, I will be presenting the economic evaluation of our study. So, firstly, we need to calculate the costs for each scenario. So, here are the corresponding items for each scenario and the corresponding costs. So, this is from the Comprehensive Traffic Management Plan for Metro Manila case studies. We are also assuming an interest rate of 4% with values from 2020 to 2024. And the ONM for traffic enforcers applies every year. And there will also be the repainting of pavement markings every 3 years. And then after the cost, we also calculated the benefits as such. So we drew a 1 kilometer radius from the intersection, and then we measured the alternative routes. So in turn, we were able to obtain the vehicle operating costs or VOC within these boundaries. So here are the vehicle operating costs. So the ones highlighted in green are the movements that were affected by the rerouting scheme. And this table also shows the difference in the total vehicle distance traveled. And also important to note that the overall vehicle distance increased when the rerouting was implemented. However, even if the distance traveled increased, the delay decreased. So to add to this, the benefits, the vehicle operating cost, so the numerical values were also calculated. So there were only for scenarios 2 and 3 because these two scenarios involve the rerouting. And then it's estimated to be negative 8 million pesos per year. So that means that in terms of VOCs, rerouting is not that beneficial. And then in terms of travel time savings, the TTCs of the alternative scenarios were subtracted to the base scenario. So initially, the highest annual travel time savings is from the scenario 3, where the average intersection delay is the lowest. And the scenario 1 has a negative travel time savings because of the additional delay caused by traffic signalization alone, which is consistent with the situation mentioned by Paolo earlier. And then for the total benefits, this is just the summary of the numerical values. And we also note that the combined traffic signalization optimization yields a 23% increase in the annual benefits compared to scenario 2. So it's quite significant. So these are the system control parameters. So we have to lead it towards the right direction. So one should give reward or a higher value or merit on the performance evaluation metrics that are favorable to goal or objectives. So we have to think of measures that would gear us to the right direction. So of course the goal is to solve congestion problem, and we will measure it based on the benefits, and the ideal outcome would be the improved overall situation in the area. So the ideal situation is to have higher travel time savings. So as mentioned earlier, for scenarios 2 and 3, the rerouting caused an increase in distance, but travel time or delay is shorter. And then we also evaluated the costs or the based on the VCR, NPV, and IRR. So for scenario 1, it cost a negative benefit in terms of the cost. And for scenario 2, it's very, very high benefit cost ratio, NPV, and IRR, and as well as in scenario 3. But based on BCR and IRR, the scenario 2 governs, and for scenario 3, it governs based on the net present value. So we think that the costs incurred for the operation of the traffic signal affected the performance of scenario 3 as compared to scenario 2, because scenario 2 entails a lower cost. So for the conclusions and recommendations, okay. So here are our findings. For scenarios 2 and 3, even though the vehicles would travel slightly farther, the travel times are shorter. However, based on the traffic KPI such as travel time delay and so on, queue length, traffic signal, and the routing is the most attractive measure. And based on the table I showed earlier, traffic rerouting only governs based on economic evaluation. So based on these different basis for evaluation, it might have varying results.
Okay. So, are you sure your computation correct?
Maybe the
Mhm.
erroneous significant number or volume of benefit came from the unit cost for vehicle operating cost and travel time savings, Prof. Can you move to the system control, Kat?
Mhm.
Yeah. So here, vehicle operating cost and travel times savings or cost is valued at 13.78 per vehicle kilometer and 43.76 per vehicle minutes. So I think this one's being used by DPWH
Hmm.
for a design speed of 30 kph.
Okay.
So maybe that's the reason why it's very high.
Is there any comment from other groups to this group? Go ahead.
Prof, we have other recommendations
Okay.
for further studies.
Okay.
Let me present po. So first, we can try other mitigating measures like policies such as number coding or truck bans and apply it in the software, congestion pricing, one-way scheme on some roads during rush hours, turning restrictions, and bypass roads. Next. For road safety, we recommend this intersection layout where we repaint every 3 years, regularly inspect the pavement surface of the pedestrian crossing near the intersection so that vehicles are already slowing down at the intersection, install appropriate signages, and provide curb cuts for PWDs and women with strollers. Next. And lastly, to use a more robust software so that we can generate detailed KPIs, simulate multiple vehicle types and pedestrian interaction.
Okay.
It can be capable of other uh, KPIs and ayun po, Prof.
Okay, so okay, so from other group, is there any comment or question to this group? Uh, I just thought your KPI a while ago. Can you go back to the previous slide on the IRR? Yeah, so this is very strange value,
Oh.
right? Like, I don't know, it's like 400,000. And if I just look at the IRR alone, so say, suppose this is number is correct, I don't know. So your conclusion should be scenario 2, right? But your conclusion there, you said number scenario 3 is the best.
I think, Prof, the choice was made because the net present value is the highest in scenario 3. So in the long run, uh, since the KPI for performance is highest in scenario 3, it's more beneficial to install the traffic signal and rerouting from day one.
But the PCR is higher in scenario 2. Anyway, so I'm not sure if the computation is correct, especially the IRR still seems very strange, the number. So it's okay. So please check again. Okay.
Okay, sir. I think we will revisit especially the values for the costs.
Right. So, and then can you check also the rerouting there? Can you go back to one of the slide earlier? The rerouting, very early. Go up, go up. And when, okay, this, no, earlier. A little bit up. There is, this one. Okay, sorry. Okay, so this one. Why don't you make a rerouting that actually making a loop? But here, this is going there, okay, and then this is also going there, right? So maybe if this is going there, maybe this one should be going there, no? Not the other way around. So that making a loop.
We'll consider that, Prof.
So because if you do this, I'm not sure why this is better. So that's question. So and then a few of your numbers is also strange in the after that in the intersection. This one, for example, so this is one thousand. This is the one that you move, right? The 1,400 something. So is it possible to make it just 2 phase rather than 3 phase or 4 phase? Of course, 4 phase is very bad. If you can make it so that using rerouting, you can only have 2 phases. rather than 3. That probably will improve a lot.
The intersection is limited, Prof, in the number of lanes. So for the east-west direction, it only has one lane for the approach, and then for the north-south direction, it only has 2 lanes for approach. So we can dedicate one lane for left turning and the other for the through and right turning. I think
Suppose you don't
that's
dedicate, what will happen, for example?
okay, sir.
Oh,
We'll
right.
test it.
So probably will help out better. I don't know. So you need to simulate.
Yes.
Okay. And some of this route probably you can also put into rerouting rather than just in the intersection. I don't know. You probably want to consider that. So it seems like the main part is from this part, right? And then also these two are actually should be together because they are straight line. Okay. And the rest from the left side from here is actually less traffic. So probably you want to reroute that small traffic somewhere. I don't know. So in that case, you can have only 2. Phase rather than 3 phase. Please consider. Okay. Thank you. Let's go to the next group.
Thank you, Prof.
Yeah, thank you, thank you.
Thank you, Prof.
Yes.
Our group,
Yes.
Abby, Ming, and Christine supposedly will be the next one.
Mayan? Yeah.
Hello,
Okay.
sir.
Okay.
Okay.
Yes, Prof.
Go.
Good evening, everyone. Good evening, Prof. Am I audible, sir?
Okay, so can you make it shorter? Yeah.
Okay, Prof. So our group is here to present our research topic entitled Optimizing Transportation for Locals and Travelers in the Province of Guimaras. So, next slide, please. So, for the introductory part, the enhancing province of Guimaras, which is our study area, is destination for tourist travelers. So, yet, beneath this picturesque surface lies a challenge that both locals and visitors alike confront daily, which is transportation. So, the optimization of transportation infrastructure and services in the province holds significant implications for enhancing socioeconomic development and improving the overall quality of life. Next slide, please. So the province of Guimaras, though small, it offers diverse attractions, but the transportation accessibility and efficiency remain concerning. So the province relies on land and sea routes like tricycles, jeepneys, ferries, etc. So these vital means face challenges like sparse infrastructure and erratic schedules. Next slide, please. So for locals, reliable transportation is essential for accessing employment opportunities, etc. Meanwhile, travelers rely on efficient transportation systems to explore the island's attractions, which contributes to the local economy through tourism revenue. Next slide, please. So here is the administrative map of the said province. So it composed of 5 municipalities, and the 2013 land area of the province is 61,000 hectares. Next slide po. So further, the province has 10 ports as shown in the screen. Next slide po. So what is the current state status of the Guimaras transport system? So first, the public transport system with fixed routes is unreliable since it does not follow a schedule. Next, with service being infrequent, other forms of transport services took over, such as the tricycles and motorcycle singles. So currently, only Buena Vista has a PUV transport
terminal. However, this is still under development, although it is already being used. Next slide po. So recognizing the pivotal role of the transportation in facilitating economic growth, there is a pressing need to explore strategies for optimizing mobility solutions in Guimaras. So this study aims to maximize the overall transportation efficiency and accessibility for both local population and foreign travelers. So next slide po. As part of the background, we have integrated relevant data sets into this presentation. So the first table is the number of registered vehicles in the province by type. So looking at the calendar year 2022, motorcycles have the most number while the buses have the least, which is just 1% of the motorcycles. Next po. The next data set is the same day visitor excursionists or visits and tourist attractions. So comparing the 2022 to the previous years, it shows the gradual increase in the tourist travelers, wherein it has 283% growth rate. So next, please. In the data per component municipality, we'll see that the Nueva Valencia has the highest number of tourist arrivals from 2014 to 2018. The table shows the consistent increase of tourism in the province, which means that the need for transportation follows. So next po. Based on the 2020 census population and housing of the Philippine Statistics Authority, the household population of the province was 187,000, wherein the working age group covers the most, which is 64%. So correspondingly, the majority of the local commuters belong to the said age group, which is 15 to 64 years old. So for the literature review, next slide, please.
Okay, so for
Let me introduce Miss Junabi for the literature review. Thank you.
So for the literature review, just a small, just a short review of the literatures on the small island transportation. No, the need for small island, the study on small island transportation, anchors to the following: that transportation in the small islands, as showed in as shown by various researches, is vital, particularly in the economic, social, and the territorial development of an island. And transportation in small islands are interdependent, particularly in island to island. And accessibility, however, accessibility issues, limited market opportunities, is affected, high cost, and of course, it is also affected by environmental factors.
Junafi, can we
Yes, sir.
can we skip the literature review and go to methodology?
Okay. Okay, sir. So let's proceed to the methodology. I think Sir Joven was actually given this part. Sir Joven.
Hello, good evening. So for our methodology, we use BEP analysis to optimize or maximize, since our data is really, lacking, sir, in this study, since most of the plans of the province is not yet approved, sir, so we can't use their drafts. So we just use the data given online or publicly posted, sir. So we use BAP and we use sensitivity analysis for our option that we use bus or ferry. We provide buses or ferries for the province. Then we will check the results from the BP analysis if that's the best option using Nash equilibrium, sir. So for the analysis, let's move to the next slide, please. So for the BEP analysis that we use for the model, we have the estimates for the cost for the column of the buses, for the vehicle acquisition, permits, etc. Then up to the miscellaneous cost, we also done the estimate, or we got the estimates for procuring the boat or ferry. And these are the numbers, sir. We have a working budget of 35 million and a population of working age of 102,000. This is already rounded up to the nearest thousand, sir. So we first get the total variable cost which is the total budget minus the sum of the fixed costs, which is are the particulars with the single asterisk, sir. We got the sum. So and for the bus we got a value of 34 million, and for the boat and ferry we got 33 million for its total variable cost. Then for the number of units or N, we got we use the formula of unit cost. So um the sum of the particulars with the asterisk, double asterisk, divided by the variable cost. So we got a value of 5.66 for the bus, and the boat for ferry we can only procure at 1.95 units. So, and then for the actual number of units, we just round down to the nearest whole number, since we can't buy a unit that is on decimal, sir. So we got 5 for bus and 1 for boat or ferry. Then we got the passengers that can be supported. If we have 5 buses, using the capacity of a typical bus, we have a 50, we get 250 number or unit, I mean passengers that can be supported by the 5 buses that can be procured.
Can we,
Then for the
can
ferry,
we, Joven, can I know the demand for this one?
sir, we have the 102,000, sir. We
100,
are targeting the 102,000 can be what do you call this? Can be supplied, sir, like that, sir. But due
102,000,
to
but you only have 5 units?
sir, because our constraint, sir, is the budget, sir. We are working on we are just working on the budget available, sir.
No, I
So
mean,
that's the why, sir,
for
we are
example,
just
5 times 50 is only 250,
yes, sir.
but the demand is so high.
So high, sir. Yes, sir. So high. So this is the only count, sir, that we can uh we think that can be supported, because our constraint is really the budget, sir. That's why we are working on for our sensitivity analysis, sir. We are working on changing the cost, which will be our delta, sir. If
Oh,
we lower the cost, how what how many units can be procured, sir?
hmm. You are the government, right, in here, or you are the private company?
Sir,
Are you the government or the private company?
we are just sir, using the data from the government, sir.
No, my point is you are doing BEP in here as a government or as private company that you want to invest
Government, sir.
by
Government, sir.
government. So if you have a government, so why you need to do that? What I mean is you just create a regulation so that this will become beneficial for the private to open.
Yes. Sir, that's why, sir, later in our recommendation, we are having a public private partnership, sir.
Hmm.
Since the government cannot carry all the what do you call this, the cost to procure number of buses or boats, sir.
Right.
So we can, so here's the answer that we'll just for our initial intent, sir, is to what do you call this, have the exact, sir, but again the data is not yet, Ma'am Juna, we can prove, sir, na that the data is not yet approved, so
Okay,
we're
okay.
just
So
basing this on estimates, sir, and available data from publicly posted, sir, online.
okay. Okay. Oh, please continue. What do you want to say?
Sir, so we can proceed with the can you go back a little bit for the BEP previous slide, please? The previous slide, the BEP.
Uh,
Yeah, there. Sir, and we tried, sir, also, sir, the combination, sir. What if we procure both, sir, using the available budget? So first, of course, we get first of course the more expensive, sir, we try to get how many ferry, since this is already the maximum, sir, for the boat or ferry only. We consider the amount, sir. Then we will just we get the difference, so we can use the remaining budget to procure the bus, sir. So we get
Okay.
two bus and one ferry. So summing the capacity, sir, is it's the same with the all bus only, sir. But the remaining budget is a little bit smaller, sir.
Okay, so
We just
I think yeah, based on this computation. So and you said the demand is how much is how many is the demand?
102,000. So large.
102,000 per
This is
year,
the
per month, per day.
this is the total, sir, for the working age, sir, already.
No, I mean look at this value. 50 multiplied by 250, right? You are saying, or 50 multiplied by 5.
Five, sir. Yes, sir.
Okay, so your capacity is 50 multiplied by 5. That is 250.
Yes,
So
sir.
what is the demand?
Ma'am Junavi, can you provide the numbers, if at least the draft can say?
So if you are saying 100,000, right? What 100,000 is per what?
Sir,
Per
100,000. Sir, 100,000 is the working age group of Gimaras. So that's the number that we assume that they need the transportation
okay.
in
So,
the province.
you need to convert that into a trips, right?
Okay.
Okay.
That's why, sir, I think in our recommendation as well, since we do have lacking of data, particularly with regards to their transportation,
Mhm.
since the local transportation plan of the local government unit is not yet approved and they
Mhm.
cannot provide us with the data.
Mhm.
Further studies should also include the daily trips and the weekly trips of the of the population to further um identify or
Okay. So,
identify the number of the need of the LGU when it comes to bus or ferry.
okay. So probably we can discuss later more detail. Is it okay?
Sure, sir.
Okay. So I think we can go with next group first. Yeah. I think you need to revise this so that become more realistic, so that I mean lack of data, it doesn't really matter if you can know how to assume. Yeah. So
Okay, sir.
yeah.
Okay, sir.
So let's discuss this after the class, so I can
Okay.
give you more
Thank
time.
you.
Thank you. So okay, let's go to the next group first in that case.
Next group, sir.
Okay. So you can go.
Abby, share the screen, please. There it is. Okay. So for our group, sir, going back to our topic, for our first topic, am I audible? Sorry, my
Yes,
voice
yes,
is
yes,
kind
yes.
of
Go. Please make it brief.
excuse me. So Mantivo to Vitali Diversion Road, with community, supposedly with community shuttle system. And the project, next, Abby, please. The project is actually located in Region 9, also known as the Zamboanga Peninsula, a region located in the western part of the Mindanao, Philippines. It is actually composed of three provinces, which is Zamboanga del Norte, Zamboanga del Sur, and Zamboanga Sibugay, as well as the HUC, or highly urbanized city of Zamboanga City. We just wanted to highlight also for that we have selected the project for safety concerns. Zamboanga faces safety challenges due to inadequate road networks, leading to not really congestion, but leading to for safety concerns due to the presence of NPAs as well, and then and also delays in emergency response due to lack of road networks. And also the region also needs critical infrastructure to develop and improve connectivity, facilitating economic growth and enhancing security measures in Zamboanga. So this is the comprehensive project encompasses the construction of the 32.46 kilometer concrete road, including the possible two bridges along um, the presented alignment in the photo. This initiative is supposedly complemented by the integration of a community shuttle system aiming to enhance regional connectivity, address transportation challenges, and stimulate economic growth while providing efficient local mobility solutions. Next, Abby, please. For context, I just put a map here of the possible zoning for future consideration or future research. The zoning per barangay of the possible barangay that will benefit from the project. So we have identified those barangays as well. So recognizing the need for the inclusive transportation approach inside those barangays. Since there are communities inside, but the road network, if you will look, Abby, can you just go back to the previous slides? I think it's not, just next. It's next, I mean. Next slide, please. Okay, I'll just go with, I think the objectives, road connectivity, as I've said, and then to promote implement a localized shuttle system, and then for the economic and social development, and the possible benefits will be holistic connectivity, local mobility solutions, and economic synergy. Next slide, please. The evaluation criteria will be we just process and generated for the divertible traffic, and then continued with the economic evaluation. Next, please. So supposedly we have the base scenario, which is the diversion road only, and then the alternate scenario with the community shuttle system. Next slide, please. So as you can see, this is the those are the NRSTP survey stations, which can be searched from the web as well using the RT application of the DPWH, and you can see the Mantibo Vitali Road, and then the primary road red, and then secondary road will be blue, and then tertiary road will be green. And you can see that there is no adequate there's an inadequate road and infrastructure going from the blue from the secondary road there at the left side of the peninsula, going to the right side, which is the national highway there, the red one. So there are no you have to go around before you actually go to the other parts of the region. Next slide, please, Abby. So you can see there from two municipality. I mean, one is from the Cebuco and also going to the Zamboanga City. So that's how far. Actually, it measures around. The road project will be 32.40 kilometers, and the existing or the versus road or the competing road will be around 190 kilometers, I guess. So Next slide, Abby, please. And I'm just showing also again the possible barangays that will benefit or will be the beneficiary of the project. Next slide, please, Abby. Yeah, just a closer look at it. And then I just like turning off the base map just to have a good picture of it for the traffic tracing. And then naming the sites that I will be use project survey site A, B, C, D, E, F, G until J. I think that's the site that we will be needing to capture all the traffic that will actually use the road project. Next slide, please. I just showed the existing road network or the competing road. Yeah. And then next, these are just the photos that we had during the reconnaissance survey we did on the start of the alignment of the project. But since there is no existing road network, we have to use a drone to actually identify where is the water flow. Where will be the possible alignment. We have to identify it through the drone since we don't have any. I think there is a unable due to safety reasons we didn't actually that because of there because of the safety issues also here around the area. So we have to use a drone that time. Next, Abby, please. Digital traffic tracing.
Okay.
Using the 2022 AADT from the DPWH as well with 13 we actually group this vehicle types from 13 vehicle types to or I just 4 to 7 vehicle types. Next one, Abby. Yeah. Next.
Okay.
Yeah, from the traffic tracing, we actually got the normal traffic and the divertible traffic as well.
How do you get the divertible traffic?
By traffic tracing, sir, I can show the Excel. I'll just share my screen. Abby, can I share my screen? Actually, I'll show also a. Wait. If you're familiar with, I'll just show my Excel first. This is actually a program that I'm using at the office to because it's already automated. I'll just have to put, for example, the traffic site, and it will get the value here from the AADT. So I'll just remove this one since it's already there. And then you get the traffic. Since I have to assume a 50-50 distribution from both ways from that AADT here. So I just have to multiply it to 0.25.
So you assume 25% of that? Or?
Yes, sir. I'll just assume 25%. For conservative also for conservative computation as well. And then from A1 here going to B1, since it's assuming that the minimum value since from here you have a 903 motorcycle. I'll just focus on one vehicle only muna. And then you have 162 motorcycle counted in traffic site B or survey site B. So as you got the minimum, since it's not an intersection survey sites, it's on a mid block. So I'll just have to assume that it's a minimum case. So you just have to you can actually select just if it's a through, a left, a turning right, or or it's in an intersection as well. So but here I'll just use the minimum. So you will actually just get the site with the minimum values that you will be using for your divertible traffic. And then turning from if the value from A going to K will be the minimum, I think it will also be the minimum value from K to A. That's why we got here the divertible traffic of 109. We got here also 162, and then from here the divertible will be just the addition of it, around 324, and then yeah, 324 for the motorcycle. I just arranged it like this
Yeah.
one.
Okay.
Okay, and then wait, I'll go to the wait. Well, how to stop sharing for this one? We actually use a program to generate for the time for the existing traffic projection. We have where we use the where we have used the divertible traffic we got, and also the normal traffic we got here. That's why I arranged it by this kind of this arrangement of vehicles. So we can just input here the normal traffic and also the divertible traffic here. You just put the base year 2022, and you can actually change it whatever year you might have. But since the data is from 2022, we just yeah, and then assuming 2030 is the opening year. And then also for the engineering inputs, we also considered the class, the type of class, if it's a one-way, two-way, dual carriageway, motorway, since it's just a two-way or a two-way lane, and then also two lanes, the number of lanes, the width, the lane of width. Uh this is also based on the observation during the site inspection, and then and then the description of the bypass or the diversion road or the project road is also here. So considering all of the computations and also for the maintenance costs and periodic costs, which is this is from the DPWH value as well, a standard computation for the maintenance cost, and then there is also a computation of the VCR of the existing, since there is no actually traffic. That's why, or there's no congestion, since we wanted a new road. We actually wanted a new road for this one. So and then the VVOC that we use, the running cost, this is from the 2019 basic vehicle operating cost. We use a running cost of for each vehicle type, and also the time cost used for it. Then for the bypass, I mean for the case, for this case, the highlighted values will be used for the next Excel sheet that we use. This is for the this is the running cost, and this is the time cost, the maintenance cost, and also the generated traffic benefits. We assume it at 10, conservatively at 10%, that it will generate at least traffic benefits of 10% from the usual traffic. And then I will share another one. Where's that? So from here, we have an input. These are the assumptions that we actually use. Since it's a 32.46 kilometer implementation year, or the construction year will be 5 years. The construction year start is 2025. It will open at 2030. the construction cost is based on the profile of the project is around 1.8 billion, and
Okay.
then the right of way is around 162 billion. And
So
economic cost is assumed to be 90%. Actually we use 12% here. Supposedly it should be 88% of the project
okay.
cost
Uh,
or the construction.
Leslie, can you summarize your
Okay, so
presentation?
so for the ecoval, sir, this is the ecoval. We have the construction cost here, and then the maintenance cost, the savings, the vehicle operating cost savings here, the generated benefits. So with the net benefit, with the economic evaluation, the base case will be was evaluated at a positive NPV with an EIRR of 36.75%, which is higher than the social discount rate we use here
Yeah.
at 10%, and also a 6.06, which is greater than 1 PCR. And the sensitivity analysis, we just use if the cost will increase at 20%, and if the benefit, what if we have three scenarios. The cost will be increased 20%, the benefits will decrease by 20%, and also a combination of the two. The worst case scenario will be 20% increase in cost and negative 20% decrease in benefits. And it shows that still the project is still viable.
Okay.
So this is the summary. That's it, sir.
Okay. Super. Yeah.
Thank you, sir.
Yeah. So I think no problem in that case. Yeah. Is there any other group or you have any question to this group? So if not, is there any other group that you want to present? How many groups do we have?
Sir, our group will
Okay,
present.
okay, good, good.
James. Okay.
So for our group, we'll be discussing the feasibility of a dedicated shuttle service program for UP Diliman. So for the introduction, so it will be the outline po. And for the background statement of the problem, so our site selected is UP Diliman with a almost 20,000 student population and a workforce of about 3,000. So this workforce includes the faculty, and other staff of the university. Then with these demographics, so 18% resides within the UP campus, while 29% lived within 3 kilometers or within 3 kilometers radius of the university, and a whopping 50% lives a significant distance from the campus. So meaning po, further from the campus, more demand for car usage, therefore longer distance travel, longer travel time. So as for the current travel time in Metro Manila, it is estimated 2.57 minutes per kilometer for the whole region, or 2.08 minutes per kilometer average for Quezon City. Na it is without a doubt the travel within the metro can be bothersome. Likewise, even UP Diliman has its own jeep route or units, also known as UP Toki. This is still insufficient to cater the demographics or the ridership. So on average, other commuters wait for 30 minutes to 1 hour in public transport terminals. So this leads to the shift from riding the public transport to bringing their own vehicles to go to the university. And this also leads to contribution to the traffic congestion in the metro. So we suggest for additional and alternative transport modes for commuters is needed. So for the research objectives, so the main objective of the paper is to evaluate the feasibility of implementing a dedicated shuttle service program. So specifically, this also aims to determine the financial and economic viability of this dedicated shuttle service. For the scope and limitations po, this study involves the conduct of a cost-benefit analysis to determine both the financial and economic viability of the said shuttle service program, including the initial investment cost, operational cost, and potential revenue streams. So this only covers the UP Diliman students, faculty, and staff, not disregarding those who resides within the campus. Only those from within the 3-kilometer radius and those living farther away from the university. For the limitations, this study relies heavily on the demand study conducted by Parata and Castro in 2020, as well as the financial data from third-party sources. So external factors are also considered since the conduct of the demand study, which may affect the validity and applicability of the findings of the study. For the literature review po, here are some of the resources, but this solely focused on the these were the sources that we used the most.
Okay.
For the methodology, Sir Aaron.
Okay, thank you, James. So for the methodology, we will divide it into the conceptual framework and I think that this is just a conceptual framework. Next slide, please. So what we did was after reviewing the existing literature on shuttle service program, we come up with our own demand estimation of the project, taking off from the study of Peralta and Castro. From there, we conducted a financial analysis, an economic analysis, and then a scenario and sensitivity analysis, and then finally a conclusions and recommendations. Okay. Next, please. So first, just to give a background on the Peralta and Castro study. Next slide, please. So what Peralta and Castro did was they conducted a survey of students, faculty, and staff of UP Diliman with a sample size of 933 to determine the demand for a dedicated shuttle service program and people's willingness to shift to that particular shuttle service program. So what they did was they developed a binary logistic regression model to determine the probability of shifting to a shuttle service. No? And then they divided the study into two groups, those that are currently using private mode of transportation, the car users and motorcycle users, and the public mode users, which are currently using public transport users. What they found out was for private mode users, it's the relative trip distance, distance of address to campus, and arrival location in campus significantly affect their probability to shift to the shuttle service. For public mode users, the relative trip cost as well, the distance and sex are the significant variables. Overall, their estimate is that around 5,700 UP Diliman constituents will probably use the shuttle, which accounts for about 30% of the off-campus population of UP Diliman. Next slide, please. Okay. So since their demand study was conducted last 2020, almost 4 years ago, what we did was to first adjust it to year 2025, which we assume to be the year that this project is going to start. So we assume a conservative population growth rate of 2% per year. So this is how we came up with our demand estimation for 2025. Later on, what we did was we projected the total demand until 2039. Next slide, please. So we had a project period of 15 years from 2025 to 2039, and we projected first the total number of shifters or users of the shuttle service program using the 2% population growth rate. No, since the data that was provided by the previous study was only on the number of users. To complete our demand study, what we need is a total demand per day and per year, or the total trip demand for this project. No, so for first is we multiplied the total number of users or potential users of the shuttle service by a factor of 1.75 to consider those people who would not use the shuttle service twice a day. So instead of multiplying it by 2, we multiplied it by 1.75. So we came up with the numbers in the second row. Then we also assume that the operational days for the shuttle service will be 200 days per year. And then we multiplied it by the total demand per day to come up with the total demand per year, or the total demand trip per year. So our estimate is around 2 million demand trips in 2025, and then 2.9 million in 2039. Next slide, please. So after conducting our demand estimation, we proceeded with the financial analysis. Next slide. So here are just the key assumptions of our financial analysis. So we assume that it's going to be UP Diliman who will implement and operate the entire project. The start date will be on August 2025, which is, I think, the same month as the start of the academic year. The number of years of the project was assumed to be at 15 years, and it will end at July 2040. For the base fare rate in 2025, we assume a fare rate of 30 pesos. I think this is consistent with the PU by the fare rate of the LTFRB for public utility buses that are traveling about, I think, about 10 kilometers per trip. And we assume that the inflation rate will be 3% annually. So the base fare rate would increase by about 3% annually. Next slide, please. Now, going on to the projection of the revenue, taking off from the total trip demand that we estimated earlier, we calculated the average price per trip. So that 30 pesos was indexed to the 3% inflation to get the average price per trip for from 2025 to 2039. And there we just multiply the demand with the average price to get the revenue per year in millions. So we estimate that the revenue per year on the first year will be around 66 million pesos, and then around 133 million at the end of the 15-year period. Okay. And then next is for the capital expenditure. So what we assume is that the number of shuttle bus that will be acquired for this project will be 62 units in 2025 with an additional 10 units in 2023. So our basis for these number is the number of units acquired based on the trip demand. No? So we also assume that the shuttle bus maximum capacity is 30, and the number of trips per day, two-way, would be 6. And then the acquisition cost per each shuttle bus would be around 3 million pesos. This is based on our market study of existing shuttle buses in the internet. And then for in 2025, when we acquired the 62 units, the total acquisition cost would be around 186 million pesos.
Can you show that 62 is enough to cope with the demand?
Sure. I might need to share my Excel files here. Hold on.
I think this is also beneficial for the other group, our group in Kimeras. They need to do the same thing.
Can you see my screen share?
Okay.
So first, I started with the total demand per day, which is around 11,000 in the first year. And then from there, I calculated the total demand on one way. So that 11,000 divided by 2. So I estimated the 62 by this 5,554. I divided by the maximum shuttle bus capacity of 30, and the total number of trips per day one way of 3. So that's 62. And then so that's how I arrive at the number of 62. Now how I arrive at the number 10 is in the first few years, I assume that this is I did the same calculation for the next few years. So I need to unhide this first. Okay. So there. So according to this Excel file, let's say in year 2026, 2027, the number of shuttle bus required based on demand will be around 63, 65.
Okay.
But to be conservative, I did not right away assume that there will be an acquisition of one or two vehicles, but instead I assume that there would only be an expansion on the number of fleets of vehicle if this demand uh, reaches 10 or more than 10 of 62, so it's 72. So if this number reaches the number 72 around this, hold on. Okay. Around this year, in year 2033, there will be an additional shuttle bus acquisition of 10. So that's how I arrive at the 72 and the 62 numbers.
Okay, good.
Okay, sir. Thank you.
Now please continue.
Right. James, can you? Okay. Okay, so I arrive at here. Okay, so for the operating and maintenance expenditure, I divided it into different sub costs. So the first one will be on the labor cost for the driver. So the number of drivers per for the entire 15-year period will be around 62 to 72. So one per each bus. And then the salary and benefits will be around 25,000 pesos per, I assume it will be 25,000 pesos per month, or about 325,000 pesos per year if I multiplied it by 13. So overall, the total annual labor cost that we estimate is around 20 to 35 million pesos. Next slide, please. Then next, I think, sir, this is also based on our previous lesson on the gasoline costs for the operating and maintenance expenditures. No, so I assume first an annual distance traveled per each kilometers per year by all the fleets of buses. Then I multiply that by an assumed gasoline price of around 60 pesos, and then divide it by the distance per liter and the number of shuttle bus. Sorry, the annual distance travel is not for all fleet, it's just for one fleet. And then I multiplied it by the number of shuttle bus of 62.
The
To
distance
arrive at,
the distance per liter is 8.
sorry, sir.
Distance per liter is 8 kilometers per liter.
8 kilometers per liter, sir.
Okay, anyway, so
Right.
just be 10 or 11 or 12. Right. Yeah, okay, anyway, so go.
Right. So based on this calculation, I was able to calculate the total annual gasoline cost of about 5.58 million pesos during the first year. So what I'm showing in the third column is just the computation for the first year. So the rest of the computation are in the Excel file. Yeah. The next slide, please. And then this is the engine oil replacement cost. I think this is also part of our lesson. So so what I did was the annual distance traveled per each bus multiplied by the engine oil price, and then the distance per engine of oil can, and then the number of shuttle bus. So the formula is similar to the gasoline cost. So my estimate is that on the first year, the annual gasoline cost will be around 100,000 pesos. Next slide, please. And then finally, it's the tire replacement costs. I assume that the tire replacement price will be around 3,000 pesos per tire. And the number of tires that will be replaced per each shuttle bus will be around 2 tires per year. And then the number of shuttle bus, of course, is 62. So I just multiplied all the variables there to come up with the total tire replacement cost of 0.37 million pesos. I think there's a typo, sir, on the last part. Okay. And then for the other costs, I assume an administrative cost of around 5% of revenue and an interest rate of 8%. Okay, next please. So for the financial indicators, summing everything up, the annual benefits in terms of financial analysis is on the one on A. So that's 67 million in the first year, and then 133 million at the end of the 15-year period. I discounted this at the interest rate of 8% to arrive at the present value benefits. And then I have the net present value benefits of 768 million, 0.47 million pesos, which is the sum of all the PV benefits for years 1 to 15. Okay. And then next will be the annual costs. So the annual costs would be based on the capital expenditure, the total O&M expenditure, the debt repayment, and the debt repayment includes the payment for both the principal and the interest. So I sum all of those to get the annual cost of around 245 million in the first year, and going down to 69 million in 2039. The high number in 2025 can be attributed to the capital expenditure and of the acquisition of the bus in the first year. So discounting these annual costs by the 8%, I arrive at the present value of costs. Then I added all of those present value of cost to get the 719.18 million pesos NPV of cost. Next slide. So here's the summary of the benefits and costs. So the NPV of benefits is around 768 million. The NPV of cost is 719. So the total net present value is 49.29 with a benefit cost ratio of 1.07 and an internal rate of return of 11.63%, which is higher than the interest rate or the cost of capital of 8%, which indicates that using the assumptions that we made, the project is financially viable.
Okay.
Okay. After conducting the financial analysis, we conducted an economic analysis. No, so we divided into the economic benefits and the economic costs. So for the economic costs, I think what I did was it was just similar to the financial costs. So it's this capital expenditure, the operating expenditure, the interest, etc. But what's different in this analysis is the economic benefits. We identified 3 types of economic benefits for this project. First one will be the vehicle operating cost savings, the GHG or CO2 emission savings, and the travel time savings. Next slide. Okay. So the first one will be on the vehicle operating cost savings. So based on the demand study by Castro and Peralta, they've identified the number of private cars and motorcycles that will shift from private mode to the shuttle service. So that amount, and then based on, I think this is based on the JICA study, the average trip length per rider in terms of kilometers is around 8.60, and the private car operating cost on average is about 18.95 pesos per kilometer. So and given the number of operational days of 200, I multiplied everything to arrive at a total annual vehicle operating cost savings of 32.50 million pesos. So what we're trying to say here is that since the 997 private cars and motorcycles shifted to the shuttle service, the entire economy was able to save 32.50 million pesos. Okay. Next slide. And then the next one will be on the computation for GHG or CO2 emission savings. So this one's a bit complicated, but I'm also taking off from the demand study on the number of private cars and motorcycles shifting to a shuttle and the average trip length per rider. So if we multiply the number of cars shifting to the shuttle service by their average trip length per kilometer, we will be arriving at a total distance by private cars and motorcycles of around 8,574 kilometers of all 997 vehicles. No? And then I think I just got this number from one of study in my work. So it's the GHG emission factors per vehicle. So this is the amount in terms of tons per kilometer that each vehicle emits in the atmosphere. So it's around 0.01 tons per kilometer. So I multiplied that number by the total distance by private cars and motorcycles in terms of kilometer to arrive at a 94 tons value, which represents the reduction in the CO2 as a result of the shifting of the private cars and motorcycles to the shuttle service. And then I think, sir, there is data on the social value of the carbon reduction. So I think based on 2026, if you will use the 2026 prices, the peso per ton is around 1,081.21. So if you multiply this number by the reduction in CO2 of 94, you would arrive at a value of 20.38 million pesos. So that represents the amount of CO2, represents the amount of monetary, the annual reduction in CO2 emissions in terms of millions of pesos as a result of the private cars and motorcycles shifting to the shuttle service vehicle. Okay. And then finally, the time travel savings. I think the computation here is a bit more difficult or a bit more complicated. But to summarize, I just came up with two scenarios, one without a project and one with the project. So the average travel time per rider is we assume is 0.41 hours, and for with project 0.29. So I just multiplied it by the total travel time, and then just subtract the total monetary travel time without a project with project to arrive at the savings and passenger travel time in terms of monetary value, which is around 30.72 million pesos. Next. So this is just, as mentioned a while ago, the economic cost is just similar to the financial analysis. So the NPV of the cost is also 719.18 million pesos. Next slide, please. So summarizing the entire economic analysis, I've arrived at an NPV benefits of around 802.12 million pesos, compared with an NPV cost of 719.18 million pesos for a net present value of 82.94, a benefit cost ratio of 1.12, and an economic IRR of around 16.19%, which is still higher than the cost of capital of 8%. Okay, next slide. And then after conducting the economic analysis, what we did was to conduct a scenario and sensitivity analysis for the financial case. Next slide, please. So this is just comparing our base case with the alternative scenarios 1 and 2 that we came up with. So for the base case, we assume that there will be no government subsidy. The type of vehicle will be gas powered. So since it's gas powered, I assume that the acquisition cost will be lower than a hybrid vehicle, which has a higher capital expenditure based on existing market prices. But I assume that for operating expenditure, since the prices of gas are very high right now, and you need to clean your fuel every now and then, the operating expenditure for gas-powered vehicles are higher than the operating expenditures of those hybrid cars. So for alternative scenario 1, what differentiates it from the base case is that there is just a government subsidy of 20 million pesos at the start of the project at year 2025. For alternative scenario 2, I also assume that there will be a government subsidy of 20 million pesos, but the type of vehicle that will be purchased will be a hybrid form of vehicle. So this resulted into a higher capex, but a lower overall OPEX. So as you can see in the results of the net present value, the VCR and the IRR, it's alternative scenario 2, which has the highest IRR or which has the highest return. This may be an indication that the overall life cycle costs of the hybrid vehicle might have affected the higher return for this project, since the hybrid vehicles have lower operating expenditure. It compensates for the higher capital expenditure that was spent earlier in the project. So
Sorry,
go ahead.
what will happen if we remove the government subsidy?
If we remove the government subsidy of 20 million, let me just check, sir. Okay. Alternative scenario 2.
Is the result better or actually worse?
The IRR for alternative scenario 2 would be 12.12%.
Oh, still good. Better than best case.
Yes, sir. But in terms of apple to apples comparison, if we want to focus on the type of vehicle, I think the comparison should be on the alternative scenario 1 and 2, because both of them have government subsidy, and the only difference between the two is the type of vehicle that was purchased initially. So for alternative scenario 1, it's 13.41%, and then for alternative scenario 2, it's around 13.83%. Okay. Next slide, please. Okay. So for this one, sir, this is just the sensitivity analysis that we conducted. So as you can see that the base fare price that we initially assumed to be 30 pesos is very highly sensitive to the IRR is very highly sensitive to the base fare price. So as you can see in the base case, if I just reduce the base fare price by 2.5 pesos, it will go down to 7.12% IRR. The same thing goes for the IRR of alternative scenario 1 and 2, which would go down to about 8.57% and 9.17%, respectively. No? So I think this is where we could justify the government subsidy, because what we assume in the base case scenario is that the demand estimation that we estimated would be correct. But as you may know, that demand estimation might go lower in the future, or might not be as what we expect it to be, and the IRR will be lower. So with the government subsidy in alternative scenario 1 and 2, there is some sort of buffer in terms of the financial return that that UP Diliman could get if they have that government subsidy. Okay. And then next. Okay, I think, sir, this is our last slides for our conclusion. On the base case, it appears that the project is financially viable with an internal rate of return of 11.63%, which is higher than the interest rate of 8%. Obviously, the government subsidy provides more benefits to the project, and the hybrid vehicle in alternative 2 presents lower life cycle costs than traditional vehicles, as evident by the higher IRR of alternative 2. And the project, we believe that the project should still be pursued because of the very high economic return, with an economic IRR of around 16.19%. In terms of recommendation, what we recommend for future studies is to consider an alternative scenario where a private sector will just operate and maintain the fleets, and the capabilities and know-how of the private sector may further decrease the project life cycle costs. So under this structure or scenario, the university will just pay an annual fee to the private sector, subject, of course, to the performance of the latter. So that's our recommendations for further studies, sir.
Right. So if you can make more strategic, using game theory and so on, I think you can actually play on this recommendation. Okay. So based on your computation, I think for private to enter at 11% IRR, that is not beneficial at all. Given that, right. So, but at 20%, so that probably a while ago you computed at 20%, 35 pesos, right? That probably will make them interested to enter.
Got it, sir. We could put that game theory in the final papers.
Correct. So, and probably how to strategize so that the private sector may enter this, no? Yeah, because the initial cost is pretty high in this case. Thank you. Any other group that you want to question or comment to this group? Okay, so in that case, thank you very much. Okay. Is there any other group that will present? No more, right? I think we have only 4 groups. Is that right? Okay, so in that case, thank you very much for the whole semester. Based on your request, so the final exam will be on the date that I already put in Moodle. Okay, coverage is from the beginning until the end. So with that, I think we can end this class. Okay, for the previous group, if you want to present, you want to consult with me, that's fine. Mr. Ahmad, Joven, right? And the rest you can dismiss. Thank you.
Prof, for revisions on our output, until when is the deadline?
I think the deadline is in the paper there.
Okay.
Right.
Just for revisions based on our.
Yes, only the paper. It's the presentation no need to revise. Only the paper.
Okay.
I think when is the deadline? Can you check when is the deadline for the paper?
On Friday, next Friday, Prof.
Yeah. So is it okay? Next Friday?
Okay.
Yeah. So you have 1 week to revise it. So if you have any problem, you tell me. We can discuss. Yeah. So thank you very much.
Thank you, Prof.
Thank you, Prof.
Thank you po.
After your final exam, so I will post the grade for all in Moodle. Please check.
Yes.
I will inform Abi.
Hey, Prof. Thank
Yeah,
you, Prof.
okay. Thank you, Abi. Okay, so Ben. Yeah. So I think you saw the presentation of the last one, Aaron and James.
Yes, sir.
Can you make a similar assumption, probably?
Sir, currently, sir, we're talking about we're just basing sir, a while ago, sir, you are asking, sir, the daily trips, right, sir?
No, I mean
So
the whole demand. You have the population, right?
Yes, sir.
From the population, you convert that into trips. For example, one family, okay, based on the say, if they are adult, population you have the age by population,
Yes, sir.
correct? So if they are adult, so they probably want to go to work and so and come back. Okay, so you can assume 2 times. Okay, go and back, right? So the same with the school age of the school. Okay, but
Sir, I ask Ma'am Junabi, sir, is it okay, sir, if we just convert, sir, for example, sir, for every 45 minutes in Guimaras, there are for example, sir, 5 jeeps in Jordan, sir, that is being used as full capacity. Then we get the total, sir, of per municipality, then convert it to the population, so we can get the demand, sir.
correct. So you from the population you convert with certain assumption, like
Yes, sir.
Aaron a while ago he just assumed 1.75. Remember?
Okay, sir. Sige.
Okay, so
For the for a while they are discussing, sir, I asked Ma'am Junabi, based on her experience in Guimaras, how many for example, sir, how many jeeps and trikes, since that is the most used public transportation in Guimaras for every 45 minutes. Then
right.
we convert it to we assume, sir, that for every jeepney there are 16 seating capacity for full capacity. Then multiply it to the number of jeeps that are full for every 45 minutes. Then we
Yes.
can we that is the number that we can compare to for the 250 demand capacity, sir, for our bus a while ago.
That one is no, you need to compute the whole demand from the population and the tourists.
Okay, sir.
Right? And then you compute the one that you just compute based on the number of total full jeepney, that is the current condition. So if then you need to check whether the actual demand can be coped with the current condition or not.
Okay, sir. Okay, sir.
Right. And then the remaining missing of the demand, that is the one that you will purchase.
Compare, sir, with the
But
BEP there.
you will purchase, right? So
Yes, sir. Yes, sir.
okay, now based on that purchase, now you have a two choice. One is using a government budget, and the other
Yes,
one
sir.
is using private.
Yes, sir.
So then if you can calculate per vehicles, okay, then you can say, okay, I know if you are doing private, this is supposed to be your cost and benefit, right? And then this is supposed to be at least you can get BEP at this point, and then you can forecast for the number of years, like a while ago, and then you will say, okay, this is the actual IRR and financial analysis, no? For the private, no? And then also for the government. So if the value is actually too small, okay, then government take over. But if you can make the strategy so that say you can increase a little bit the price and then let the private take over, then government don't need to spend any budget.
No, sir.
Is it possible to analyze that way? So instead of focusing on the BP, that as if the government is the one that's supposed to buy everything, operate everything, can we strategize? Maybe government and private can be partner.
We will try, sir, with so we can solve the demand, sir.
Yes, and you did not show the demand, so I don't know whether your computation and your computation is a little bit strange, isn't it? Only 250 you compute, and then the demand is 100,000. So I got confused there.
Yes, sir. We get that, sir.
Right. I mean, 250 compared to 100,000, that's very big.
Yes, sir.
So I want to know that 100,000 is per what? Per year or per month or per day? I don't
Sir,
know.
that's sir. That's only the working the total, sir. I mean the
Population.
body count here. Yes, sir. But
So
not actually the for example, sir, the peak are not that
okay,
sir.
so please put that into trips.
Yes,
Okay.
sir.
You can assume anything that reasonable. Okay. I think look at the work of Resi and Aaron a while ago. I think they make a lot of assumption. Okay. Of course, any model you need to assume, but as long as you tell the truth, that's okay.
Okay, sir.
I hope I hope you can finish in 1 week. Is it okay?
We'll try, sir.
Okay. So if tell me if you need some more time, that's okay. I can.
Okay, sir.
uh,
We'll update, sir, within the coming weeks, sir.
Yes. Okay. So thank you very much in that case. Yeah.
Thank you, sir.
Thank you, Prof.
Thank you. Okay.